I remembered this time. And the link is correct. Wonderful. And the link is correct. Cool. Did I record? So I've done a lot of work off stream, mainly the custom servo backs and the power switch holder. But did I record an update video for that? I don't actually remember. If I didn't, I'm going to right now though. Also, if it wasn't clear already with this design, there's not going to be. I just finished modeling the customs. Okay, so that's where I left off. The power switch holder is now finished. I'm not super happy with how it looks, but it's definitely good enough to continue. And the cool thing about this design is that it's screwed onto the frame. So if I want to change it, I don't have to reprint the whole frame. I just have to reprint the power switch holder. But I mean, you can see it slots into here. If I can go into here. Right, so if we make the power switch invisible, this is what it looks like. It does not like screw in or anything. It's just like a friction fit, but the way the power switch is, that's how it's meant to be inserted. But the reason I don't like how it looks is like it kind of overhangs weirdly. I'd like to see it like smoothly transition from this face to probably this edge, but I just don't care right now. And it's definitely possible because it's printed on this side, so I can make this side look like however I want. I'm gonna show. I have it in real life. And there it is, printed. Nothing special. I actually don't have any extra power switches to test it out, so we're waiting for those to arrive. Okay, I was just recording a clip for the YouTube video. What up, Dave? What up, Eleanor? Elena R. How much will the kit cost approximately? That's a great question. It's looking so okay. It's important to note that the servos and the PCB will be included. It's important to note that the servos and the battery will not be included. Battery is not like 100% not be included. Servos, there's a very high chance it will not be included. So with that in mind, it might actually cost less than the transmitter. We'll see, because there's no screen or anything. Less than 100. Less than $100. It's I have a Notion thing where I'm keeping it. I'm almost ready to open pre-orders actually. Although it doesn't really matter. I'm gonna open the pre-orders once the next video comes out. Okay, let's see. Oh, the Teensy actually costs quite a bit. The Teensy's gonna cost $31. Just like, yeah, that's gonna increase the price. It's probably gonna be a bit more than the transmitter, but not by much. Not by much. Yeah. Maybe on sale it'll still be 100, but so not including the battery and not including the servos, probably $150. Give or take. I have most of the things priced out, but I don't have everything priced out, so it's hard to say. You missed all of last stream. That's okay. Send it with my remote. Yeah, I will be bundling them together 100. So basically I'm going to make the remote control on sale every time I release a new project that the remote control can control. And so I guess it won't be like a bundle per se, but because I don't know, maybe I should try again. Shopify doesn't have bundles built in. It's really annoying. I guess I could make a separate, ooh, maybe that's what I should do. I should do a separate product that is the bundle. I was thinking, because I have 2 separate products, right? So like if you click one product, you'd be able to like add the other one to that order, but if I just make another product, which is the bundle, that would make a lot more sense. I don't know why I didn't think of that. Yeah, so I will sell them bundles. I guess hey Vondra, is where I'm at. Can't wait. Yeah, dude. So a ton of people are waiting for this, so I'm looking forward to getting it out. No. You got the remote on sale, so you're not gonna. The $99 price is the bundle price, so you're not gonna be saving. I will make sure you will not be. Trust me, you got the best deal for that. Yeah, the 20% off is the bundle price. Dusty, we are working on the leg. I think since last stream, I made the custom servo bath, which turned out really, really nicely. I still have a shit camera, but it is what it is. So I'm able to reroute the wire wherever I want. Basically, I have three separate holes. It's hard to point, and then one on the top. And then the axle screws directly into the top. There's a heated insert in this case. I got lucky. The motor is here. So we have the gear here. The motor is here. So there's a bunch of empty space on this side. Enough empty space for a heated insert so I could screw the axle into the top or into the case. I know why I didn't try this for the original, but I wish I did, because holy shit, it just makes everything so much easier. It's literally going to take 10 centimeters off the thickness of the legs. It's crazy. Yeah, I know, it's a fantastic way to go. It's making the legs thinner. It lets me reroute the wires however I want. And the axle is like, it's a part of the case now. It's not its own separate piece. Because remember before, oh, for Christ's sake. Remember before, the axle was this piece. I had an entire separate piece just for the axle. And this piece is 10 centimeters tall, about. This is gone. I no longer need this piece at all. Because the axle is connected directly to the servo now. So, yeah. One thing that's, before I do the leg, which is a bit annoying, is that this servo is not the actual height of the real life servo. It's a bit hard to show it, but so I already know this face is 4 millimeters above this face, or actually it might be 0.4. It's either 4 or 0.4. It's 0.4 millimeters. But then in real life, it's 3.4 in real life, give or take. So, and the reason that is because I'm using the red servos, and in this, it's the blue servos. It's 3 millimeters off. And I'm not entirely sure how I'm going to go about fixing that. Ideally, I just make a different case that's 3 millimeters lower and just hope it works. That would be the best solution, because this part of the servo above the little screw wing things is exactly the same height, regardless of blue or red. It's the lower half that's taller with the red. So if I can make this case 3 millimeters shorter, if I have enough room, that would be ideal. I'm going to try that right now. I'm going to try that at least. How are you so active? Yeah, getting the wires out where you want them, it is very handy. Yep, I completely agree. Folding it, washing, and watching YouTube, nice. This man streams throughout my afternoon. Do you have both? I doubt that would make it taller for no reason. Yeah, I have blue ones and red ones. No, there's definitely a reason. I'm just hoping that I have 3 millimeters to spare. Pretty sure I do. I guess we'll find out. Because I measured the inside in real life, and there's like a motor and stuff, which I already accounted for. Here. So like this motor, this is the size of it in real life. So from here to here, for the red servos, shoot, I should actually, I'm gonna open up a blue servo. Is this, yeah, this is the blue servo. I need to open up a blue servo. I actually haven't yet, but it's the shorter one, so it shouldn't be an issue. Actually, what I should do, I should put this case on the blue servo because it's designed for the blue servo. Oh, and by the way, just to show this, this is 0.4. This distance, like this gap, is 0.4 above this. I tried to make it so this gap is also 0.4. So both sides are 0.4 above the frame. And I'd like it to be that way for the red and the blue servos. Right, so let's see. Oh, it's 2 a.m. for you? Yeah. What does that mean? Wow, that's 5 hours. That's, Jesus, 7 hours? Does that mean you're in like Europe or something? That might even be like freaking China or Japan. Romania. Was not going to guess that. Yeah, with the blue, the motor barely sticks out at all. Oh, that's great. Okay. Well, let's get this case onto the blue one because it was designed for the blue one. Another cool thing, I can take the back case off without having to remove the servo mount. Although I do have to remove the axle. If it's 2 a.m. for you, I mean, I'll probably... Well, not probably. It's Thursday. I may be streaming when you wake up. If you wake up early enough. Uh-oh. Okay, there's a slight issue with this. I took the servo out of the top case as well. Oh, no. So I've got to work on this process. Oh, there we go. Okay, we're back in. I mean, I guess I'll just leave it like this. All right. I'll get the red servo ready. Well, it's ready. It's right here. And then let's try to do the blue one. I did it. Man, I did it backwards. Yeah, definitely less space here. But the case, this should be good. I'm going to take the rubber band off. This does not need to be waterproof, and it just messes things up. Okay. So, oh yeah, that's more than enough space. Beautiful. All right. I should have, okay. I'm de-waterproofing it. You're gonna have I mean, the rest of the Hexapod isn't waterproof, so I don't think making the servos. Although, and by de-waterproofing it, I mean taking the rubber gaskets and everything off. But I'm now realizing there's literal giant holes in the case. So, in the back case that I custom made. So you'll have other issues. I mean, this looks great. The reason I'm testing this is because I need to make sure it's 0.4 millimeters on both sides in real life as well before I continue trying to fix the red one. All right. It's looking good so far. Now we can attach this. Do not over tighten that. All right, here we go. Do I really not have an extra? You watched a video with a guy making an LED face mask out of PCB panels. Yeah, give the face give the Hexapod a face. That would be that would be sick. I would really like that. And there's mounting holes for it, and also the wires are broken out in a way that's hopefully will hopefully will let me plug in, you know, what I need to. All right. Is this even the right one? Do I have to reprint it? Oh my god, it's not even the right one. All right, sorry. I changed the servo mount, and I apparently only printed one. I only printed one new one. God damn it. More unscrewing, I guess. At least I don't have to manually unscrew it. Alright. This one comes off easier. Alright. What a truth. Okay, I can't... Jeez. I can't even put it on because of the axle. Okay, here we go. Holy crap. So it fits, barely, but it does. It's like a perfect fit, which isn't necessarily good, but it doesn't really matter. Actually, no, this is good. I take it back. All right. We don't really need this. I mean, I don't need to screw all 4 in. Just 2 is fine. Honestly, 1 would be fine, but... All right, moment of truth. Here we go. I don't know if this is good or bad, but it appears to also be 3.4 millimeters. Okay, let me check the bottom first. The bottom's 0.4, like almost exactly. It's 0.44. The top is 2, so it's 1.4 millimeters lower. Huh. .2. So it is lower, but it's not 0.4. I mean, that's probably because I can't screw it down all the way. But 2 millimeters is quite a bit. And it doesn't have to be perfect. But it is, I mean, it should. I mean, let's lower it by 1.8, right? .2. All right, and it should be 0.4. So for the blue, it needs to be 1.8 different, and for the red, didn't I say 3.4? Okay, but still, that does mean that I'm able to do it, right? So I can, as I'm printing this, I can continue with the assumption that I will be able to make it exactly like it is in CAD, which is 0.4. Yeah, a 0.4 millimeter distance from these two faces, and then 0.4 millimeter distance from these two faces. Because currently that's not the case, but... Okay, but how do I properly. I guess I can attach it with an offset of 1.8. Or I can actually just make this part of the servo lower. When do I add the servo? All the way in the beginning. Is that possible? Can I just extrude this 1.8? Yeah, all right. So that's kind of what it actually is. These currently, like this is the short servo. The blue is the short servo. Googly eyes. I've got googly eyes. But yeah, those like circular screens that you used for gauges would be so good for eyes. I mean, this is 1.8. I guess my question is like, why is it not able to go all the way down? Because like it appears to be. It's not like there's a big gap or anything, but I don't know. I guess the servo just in real life is a different size. All right, so where am I joining this? Here, I think. Where is this sculpt? What is this? Isn't this a new body? Can I join? Body 2. Okay. So when I'm doing this join, what the hell is this? Oh, this is the servo mount. Sorry, I meant when I'm doing this join. Why does this disappear? What's going on here? Should this be a component instead? Yeah, I think that's the case. No. What? Why is this invisible? Okay, I can't add this component under this, but I should be able to at least join it. Oh, Christ. Seriously. It doesn't matter how I do this. There. Okay. Okay, now when I do this join, why does it keep disappearing? What is going on? It's right here. This doesn't, I don't understand. This is a component. This is a component. What is... So if I just press join, and then click this, why is it working now? Why did that work? Whatever, man. Okay. All right, and then delete this joint, or joint. Sorry, I kept saying join. All right, we've extended the height of the servo to match real life. This is the blue one. Although now that we've done that, this is too tall. This needs to be, I said 1.8 shorter. I didn't. What is happening here? Oh. All right, it looks like the height is this extrude right here. Yeah, it's that. Yep, it's this one. Okay. So I want, oh, look at that. Bottom height offset. That's convenient. I made a variable already anticipating this exact problem. Alrighty, bottom height offset. Literally all I have to do is subtract 1.8 from this. What is 4.4 minus 1.8? 2.6. Now watch this break everything. Yeah. Okay. I mean, it's definitely good, but okay, so these fillets break, this breaks, but frankly, that's not even needed anymore. This fillet breaks. So it's just a bunch of the useless fillets. All right, so I'm just gonna delete them. What is this scat? Oh. That reference breaks, I guess, but why is this breaking? Oh, there's nothing to cut? Oh, I see, it's this, yeah. But there's literally nothing to cut for some reason. Oh, wow, because I'm going all the way up, yeah. Huh. Okay, I mean, can I make this taller? Yes, the difference is only the bottom housing. Exactly. Why would the 3D printing housing need to be larger? If I just change the bottom, case, this doesn't need to change, right? What? So if it's either design with a change. Well, I mean, the idea is like you have your red servos and your blue servos, and depending on which servo you use, you're gonna just print a different bottom case, and nothing else will need to change. Literally nothing else will need to change, as far as I understand. That's my idea, at least. Okay, this. Let's just do 5. So if this is only 5, then we need to increase this to 4.9 to compensate. So it's as if nothing changed. There we go. Okay, now I'm hoping if I now subtract 1.8 from this, which is 3.1. There we go. There we go. Only that chamfer breaks, and I don't even want the chamfer anyway. Perfect. Perfect. Okay. This is good. This part's a little weird. I'm not even sure if I'm going to use this, to be honest. Wouldn't I just always be using this hole? Yeah, I don't even need this hole. It's only this one or this one. Wait. Nope, nope, I do need this hole. I need all 3. That's funny. Okay. Fair enough. Now, how do I... Is that decent? I want like a cut. Hold on. Before... I need to go before this motor cut, which is here. Oh, I see. Okay. That's when I do the joint. Okay. Okay, but when do I do... When do I do this hole? I'm reordering this to make more sense. There, okay. Okay, so now I should be able to go here, do the chamfer, and then do the motor cut. There we go. Printed on this side, so this is fine. Can I do some sort of fillet now? Whoa. It's probably too high. There we go. The reason I'm doing this is because the motor... From experience, the motor like squishes the wires right up against this wall if you're not careful. So that's why I'm doing this. I think this is good though. What is the size of this? It should be 0.7. I'm going to be having heated inserts that are 4.5. This does not need to be 7. Holy shit. So the distance between this and this is 7. Wow. Okay, I mean, let's make it negative 4.5. Because that's all it needs to be. Right? Because I have heated inserts. I mean, I plan on you. Oh, they came in the mail. Forgot. So I bought a set because I'm going to be using like I'm going to be using 8mm heated inserts. They're really long compared to normal. But then I'm also going to be using, I'm thinking 4mm, which are, you know, short. So, okay, I do have 4mm. Let's do this 4mm. So that distance is 4.5. I want it to be 4. Okay. So, all right. Yeah, this looks good. I could probably, maybe we add a bit more room here. What the hell? Oh. Sure, but how do we start? How do we make this lower? Is there any way? Where would I go about doing that? Because like this thickness is 3mm. That's, I don't think it has to be that thick, to be honest. I'd feel better with like 2mm, I think. Maybe 3. I'm just worried I'm not going to have enough room. I mean, it doesn't hurt to try it, right? I guess we just try it. All right, so 3D print this, okay, and this is going to be servo case blue. Okay. So, okay, 3.1. I don't remember. What does this number even mean? It doesn't really mean anything. Hey, Reynold, what's up, dude? What's wrong with the legs? Basically, I'm redesigning the entire Hexapod, and because I've redesigned the servo, well, the servo mount's basically the same, but I'm creating a custom servo case, which allows me to remove a part. So basically, it's going to be 10mm thinner, like everywhere. But that means I have to redesign the whole thing, basically. Have a good night, Bondrew. See you later. Base servo. Large servo 2. Large servo 1. Yes, exactly. So like large servo 2 would be the blue servo. Large servo 1 would be the red servo. You have a different bottom case, but they end up being the exact same height. Wait, why the tall servos? I mean, it looks like you made these base servo and large servo 2 exactly the same, which is good. The center and the bottom are longer, right? I think. I mean, it doesn't matter. It doesn't matter if the center. What matters is the top is the same, right? And it is. The center and the bottom are longer, but I'm replacing the bottom, so I'm just going to make the bottom longer for the short one, right? So they both end up the same height. I think I know what you mean. That probably made no sense, but okay, I wanted to update this and see like if it explodes. Well, it kind of worked. Where'd it go? Yeah, I mean, that's still 0.4, which would make sense because I did that. Oh, yeah, that's right. Hey, dog. Yeah, and I said, hey, dog. We're just working away. You will want to do the same for all the leg servos? Yeah, we're going to do the exact same. What? I don't know what to tell you.
Be sad if one of our cats were to lose an eye.
An eye? That would be impressive.
Whoa.
What?
I like it. It looks like a little cartoon.
What, this?
Yeah, it's adorable.
Should I make it white?
For the art.
I could.
It's really cute.
You like it all gray?
It suits your personality.
Thank you. Okay, so I think I need to increase... Oh, no. It's Suki.
No, she's grabbing.
She's...
Say hi. She's trying to escape. Your head is in the way. They don't care about you. They just want to see the
I promise you. Well, they don't care about this. They
okay.
I don't know. What do you guys care about? A portal creation? Yeah, it kind of does. Sure.
Get it. Where's Tika?
I don't know. Okay. For the red one.
I have to go to bed relatively soon, so I'm probably gonna go read for like an hour and then.
Okay.
So.
Cool.
I don't have to be at work until 7 tomorrow, so I get to sleep.
7 a.m.
Yeah,
Jesus.
sleep in.
That's sleeping in. That's crazy.
It's exciting stuff. And then I work tomorrow, Saturday, Sunday, Monday.
Cool.
And Tuesday. I think I work 5 days in a row. Okay, bye.
Wait, oh my God. So when are you getting off?
I had today off, and then I have, I think, Wednesday off. And then I have the weekend off.
You have next Wednesday. Okay, nice.
Yeah.
Cool.
See, they want a cat cam. Give the people what they want.
They
had a cat cam at
they
our
want
other
a
house.
They want a hexapod.
Didn't we have a cat cam set up at our other house?
I don't know.
I think you did.
I don't know. Probably. It's probably that camera over there, but it's not set up right now.
Well, I feel like you should set one up.
You've been spending too much time with your robot. I mean, it's better than playing video games.
It is significantly better than playing video games. There's been phases where he plays League of Legends way too much, and it's
oh my God. Okay.
Annoying.
Guess how long it's been. I checked at trivia yesterday. Guess how long it's been since I've played League.
Like 2 months.
It's felt like 2 months. It's been 4 weeks. It's felt like 2 to 3 months. I know. It's been. I've got so much. No, I haven't played it in 4, but it's felt like so much longer. I've gotten so much done. Can you imagine if I just do productive things? It's crazy.
I've read like 4 books in the past 3 weeks.
How much will the kit cost? That's nice.
Yeah.
So the kit will not be, unless I can be convinced otherwise, the kit will not be including the servos, and it will not be including the battery. It's probably going to be around 150.
You play mid?
I do play mid, yeah. Yeah.
You just got that mid personality.
You can look up my account. It's my name, but not robot. It's just Acer.
You're just so mid.
Yeah, what do you do in your free time?
I read. I'm knitting a sweater. I started watching Star Trek.
You just watch Supernatural. Don't lie.
Listen to this. I've watched 14 and a half seasons
That's
of Supernatural.
Not a good thing.
14 and a half seasons. And then
Not a good thing.
Netflix finally decided to kick me out because I've been using my mom's account. And it finally, literally, I was like, okay, I'm gonna finish the season. And it was like, you don't belong in the household, so now you have to pay. So
let's get free. I get free time. Natalie Natalie gets free time.
I get free
It's
time.
just our free time doesn't really overlap a ton.
I read. I watch. I'm watching Star Trek now. Brave New World season 2. It's really good.
How is watching shows different than playing video games?
I finished that like 2 weeks ago.
You did make a blanket.
I'm making a sweater right now. I'm knitting it.
Piracy fixes all.
I like to do house projects.
Okay, how is watching 14 seasons of Supernatural different from playing League of Legends?
Because I would crochet when I'm doing it. Or walk on the treadmill. So it's not like I was like being lazy. And also it's really good.
That's fair. That's honestly fair. All right. Okay, what do I need to do to this to make it work for the red servos? I've completely lost all my train of thought for some reason.
Please make a sweater for Acert streams. I asked
Ryan
if he wanted me to make him a sweater.
She literally is making a sweater.
For me, not for you.
I
wouldn't wear it.
I am technically making money right now. Not directly, but what I'm doing is progressing towards, selling Hexapod kits. So what are you doing? No, you don't have to be making money in your free time. You make enough money in your job.
I do.
We need them to stop bitching about the heat. Yeah, Natalie, turn the heat up, please. It's so cold down here.
It's not cold down here.
Stop turning the heat down.
Have you tried putting on another layer?
Yeah, my.
Have you tried like standing up?
No,
and moving around.
I haven't tried standing up. I could.
Yeah.
Anyway, please leave.
I can't believe I'm being kicked out of my own basement.
It was 3. Yeah, the height difference, it was 2.2 and 3.4.
The cat better get all the luxuries it deserves. They get 2 cans of wet food per day plus treats.
Okay, 2.2.
And Suki, the one I just showed, she screams a lot, so I just give her food from my plate too, which I know is bad, but like, she just screams so much. I just give her little pieces of chicken. She deserves it.
It was 3 millimeters.
She stole a piece of sushi from Ryan's plate the other day. It was pretty funny. She was so fast, wasn't she?
It's so hard
when
to focus right now.
When she stole that sushi right off your plate?
I think I need to make this full. I think I need to make this bottom height offset. I think I need to make this 4.3.
Yeah, that one I showed was Suki. Momo is doing great. He's sleeping upstairs on the couch right now.
Blue, red, blue, red, blue, red. Perfect. I think we got it. It was tough, but I think we got it. Servo case, red.
I missed your dreams, chat. They were cool. These people are cool too, though. No offense. I'm just saying I knew people in his dreams.
Oh my
chat.
god. Ouch, guys.
Sorry. No, I didn't mean that like that.
Reynolds actually from Dreams.
Is he really?
Yeah.
Oh my god. Wait, what was his username for Dreams?
Probably Reynolds.
Oh.
Yeah, good vibes until Natalie just completely throws you guys under the bus. Oh my lord. She calls you guys boring.
That's not what I said.
She was like, you guys are lame-o.
Okay, you can rewatch the VOD. That's not what I said.
That's what I heard.
I'm putting words in my mouth.
I think this is good. Can we print these? Printer number 1's back up. We got the memory card in. Worked perfectly. Kind of annoying I had to do that. But,
All right, I'm actually going upstairs.
Thank God. No, I'm kidding. I'm not kidding. All right, bye.
Actually, I think I'm going to bring my chair down here and just sit.
I would love that. You can spend time with me. That would be so nice. Here, come on, bring a chair. I'll even set the camera up so it faces you instead. You could pretend like you're doing the work. Even better, you don't even have to pretend. You could just read chat. It's like a just chatting plus robotics stream.
I'll just do the voiceover.
We're not bored. No, I like you guys.
I also like you guys. I was just making a statement saying that I missed Ryan's dream chat because I knew them. We would chat every night before I would go to bed, just like this.
Well, maybe you can get to know these guys. Great. Okay, we've got servo case blue, servo case red. Bring a chair down. Come on down. We got tons of room. Tons of room. Look at all this. Well, I can't really. No, I'd turn the camera. I just don't want to because. Dude, why do you need to see my screen? To talk to chat.
Oh.
I thought.
Can I?
Since when do you care about what I'm doing on the screen?
You're so right.
Yeah, exactly. You'd like get your tablet or something. You could be my moderator. I don't have any moderators. I guess you could. She's using the cat as a mouse. That was a confusing sentence, but I got there. Yeah, as like a computer mouse. That's funny. Bye. Good night. Okay, we've got the blue and the red. You'll notice a very slight height difference, but that is the difference we needed. I know for a fact I need to have supports on. Did I save it? I actually did. Wow. All right. So slice. These should be the exact settings I need. I really hope I didn't mess this up. I don't think it needs to be that thick, but it is supporting kind of like the axle. I don't think it matters though, to be honest. Okay, is this the red? Yeah, this is the red one. This is the blue one. Essentially the same thing. I think this is gonna work, but I gotta be careful with saying that because once I say that out loud, things tend to not work. But let's try it. Print plate. P1P1. Oh my god. Dude, that's sick. Okay, so I thought you were gonna be using the circular screens. Oh, look at the eyes. That's sick, dude. Basically that, but with the circular screens. And if you don't know what I'm talking about, definitely look it up. This is sick though. All right, that is blue. This is red. All right. As we're doing this, let's start on the leg. Oh, that's red. Okay. You can't press enter. You just have to like, there we go. All right, let's make sure it's still correct, and then we can actually get to work on this. I didn't mean to save that. I need to update it first. Okay. And that is 0.4 millimeters. That is 0.4 millimeters. Perfect. Uh-oh. What's wrong with this sketch? Oh, a sketch plane. Oh. Can we redefine the sketch plane? Here we go. Yeah, that didn't... Oh, that fixed the entire thing. Wonderful. All right. That didn't change anything, did it? No. No, that didn't change anything. Right? I don't think it did. No. Okay. All right, we're good. Yeah, Trey, if you don't know, I have a custom like Arduino controller that is like perfect for these kind of things. Although you could totally add like a Bluetooth module, maybe, and connect it to the Hexapod. Although I don't know, I've been right now it has an NRF chip, and I built a controller that also has an NRF chip, and it works flawlessly. I like having the screen to display data and stuff. But going the Xbox and or PlayStation controller route is definitely valid too. Actually, today and tomorrow are the last days you can get the $20 off of the controller. The range is insanely long. It's like, I mean, it's like 1,000 meters or something. It's plenty long enough. Okay, this is not good. Did it? I might have to stop the print. Oh, I have to stop the print. I have to stop the print. Okay, my bad. I'm glad I caught that. See, this is why you always scroll down to the bottom. I would have noticed that this is not okay. It's literally printing in midair. I don't know how I missed that. Oh, yeah. So if you have experience interfacing with an Xbox controller, you definitely would be able to. That's awesome. So I'm breaking out 7 pins. I don't know if any of them, I don't know if you need like SPI pins or something, but I'm not, so just the Hexapod, it has NRF support, okay? But otherwise, we're breaking out the 5 volt, the 3.3 volt, the ground, and then 7 pins. What are those pins? I mean, they were just every extra pin. I'm not entirely sure, to be honest. So I don't know, like, what do you need to interface with an Xbox controller? Like, what do you need to connect to this Teensy? Oh, and it's at Teensy 4.1. I don't think I mentioned that. Yeah, would it be like Serial or something? How often do you create a design that is not possible in real life? I used to a lot, but I'm just always designing with that in mind. So I guess now pretty much never. Like even this was 3D printable, but I need to fix it. And it's an insanely easy fix as well. It's just changing this to like 0.4 or something. I mean, I don't even need a chamfer, to be honest. What's this chamfer? That's also 0.4. Okay. I mean, that alone should fix it. 3D print. Is this blue or red? I don't. This is blue. Okay, change the variable to 4.3. See how it raises. Wait, that doesn't make any sense. If it's raising, then this is the blue one. The shorter one should be the red one. I'm just going to delete both. All right, let's try this again. So this is the taller one. The taller one is the blue one because the blue is the shorter servo. So the case is taller to compensate for that. Didn't really matter that the name is wrong, but. Okay. Let's try it again. I should be able to reload from disk. Okay. Perfect. Let's slice. And let's actually fully check. That is much, much better. Yep. Perfect. It's only 20 minutes. Would have been like 45 minutes if I only had one printer. Ooh, it works with Rust. That's cool. SPI or serial. Okay, cool. So how does SPI work? Because like, do you need to use certain pins? Because I know this doesn't really say. That's annoying. Don't you have to use certain pins, or am I thinking of something else? Isn't it like CS, Mosey, Miso? Or is it something else? Can I get a pinout that's not sideways? Thank you. So what Right. Is this SPI? SPI port. Yeah, it's the CS, Mosey, Miso, SCK. Or is it serial? You said SPI or serial. Okay, so the blue are serial. So what, you just need TX4 and RX4, for example? 17.6. Does that... I'm looking for the Bs. All right, so 1716. This is TX4 and RX4. Is that enough to? So these are the B stands for breakout. So this would be enough. All right, cool. So you're good. I already ordered these, by the way. I mean just 5, but still, I'd rather not have to change it if I don't have to. So I mean, these being the serial ports, yeah, that's awesome. Okay. In hindsight, I should probably label them that. Maybe. Not sure. I mean, these being labeled 30, these numbers mean literally nothing. Like 41 is A17, A16. Yeah. I can update that. But they're available. I mean, the ones I've ordered aren't going to be shipped. Those aren't going to be sold. PCB would not like PCBWay would not like it if I was selling the PCBs that they gave me for free. Did I start the other print? No. All right, also looks good. So should I print what's on GitHub? Oh, Jesus. I mean, you can, but I wouldn't. If I were you, I would just wait. Because the GitHub that's available, I mean, technically both GitHubs are available, but I'm saving all of this new stuff to my new GitHub, which is Acert Robotics. The previous one was just my personal GitHub, but I would definitely wait. You can order the servos though. I would do that. If I were you, I would order the servos. You have two choices. You can go with the expensive choice that is more powerful, or the cheaper choice, which is less powerful. But I've been developing on the cheaper choice because I need to make sure it actually works for the cheaper ones. Which are linked somewhere. Dude, what is wrong with this website? Give me a second. Christ's sake, man. All right. I don't know how that happened. Yeah, Alabama, sure. These are the servos. They're a little bit more expensive than this. This is like a one-time sale thing. They're like $40-ish. But I mean, I'll send you the link. Yo, you have some in stock? So that would be awesome. It's either these or there's blue ones that are the more expensive ones. Is it these? No, yeah, maybe. So these are like, this is interesting. Don't buy these. Just search DS Servo 3235. Yeah, it's these. Oh my God. They upped the price on these by a lot. Holy shit. These 3235 Pros. You don't have to get the Pros, but I mean, look, if you have the money, you know, this is the exact, when I say the blue servos, it's these. I mean, and you can see you need to buy this 3 times to get 18. Because 6 times 3 is 18. So, I mean, it's $450, which is a lot. But I will link these. They have 2 reviews. I'm a little worried. You get your... I don't know why TS Servo. What about the... Yeah. 16 sold is probably fine. Why are these so cheap? Oh, early bird deal. That's why. I'm just looking for the listings, like the listing that I bought them from earlier. I can't really find it, but you don't want 270, you want 180. You don't want 25 kilogram. 25 kilograms cheap, more expensive. That's weird. 45 kilogram too, in the same size. That's interesting. At least I think it's the same size. Anyway, I mean, these are the ones you want. I personally would buy these, and even though they've only sold 2, oh, 5,000 plus sold? Oh, no, wait. Are these the pros? These are the pros. Okay, so this store is legit. But they've only sold 2 from this listing, but I don't know, try them out. Let me know. Yeah, DA or DS? If you mean DS, then yeah, 3235 Pro. If you have them, I mean, that's, you don't even have to buy them, which is awesome. But all right, anyway, enough of AliExpress. If you're worried about getting the wrong ones, just order one. Just so, like, in the absolute worst case that you lose your money, at least you didn't lose more money. But AliExpress is pretty good with refunds, to be completely honest, from my experience at least. The only issue I've ever had, one time I ordered 12 servos and just got 2, and I got my money back. That was very unfortunate, though. That was, like, kind of depressing. All right, I'm going to check the printers. We're good to go. I'm going to clean up my desk a little, and then we're going to work on the leg. Let's do it. Okay. This is for the red. So if I save this and then update, it's gonna be wrong, I believe. I think I got that error because it was like it tried to update while it was saving. Nope, that's right. Did I guess I was just on the other one. I might have done this wrong. We'll see. Regardless, I will end up with exactly this, which is a 0.4 offset with that face and a 0.4 offset with that face. So I'm gonna continue working now. Okay. What are we doing? Basically making this. I don't... The only thing that's staying almost exactly the same is the tibia. I don't know if I can, like, just, like, literally take the tibia and put it into the new one, but... I mean, it's not that big of... I mean, I know exactly... I have it right here. I can just remake it. It's not a big deal. Although remaking the spring is going to be kind of annoying. I like the spring. It turned out really well. Let's start with the Coxa. All right. So, going into leg. It's read only. That's not good. Can we make it editable? I think we should... I don't want to pay for this shit, but... All right. Yeah, this being read-only is fine. I'm not editing it. So we have leg. I want to start with the servo mount. Okay. This servo will be the Coxa servo. I guess I'll make the leg go out this way. Maybe this way. Or maybe to the right. It doesn't really matter. Okay. So this servo is this, right? This servo, okay? That's the idea. I'm realizing now my servo mount is completely gone. There we go. Okay. Yeah, I mean, the leg doesn't really need to know what the frame looks like pretty much at all. So that's good. All right, we've got this. Great. I think we should just start with a second servo mount. And this is going to be the the femur. Wow, that's, I mean, this is, look at that. Oh, wait, actually, never mind. I was going to say it's centered, but it's actually not. I don't even know. Hold on. Can we name this? No. Whatever. All right, let's try again. It doesn't really matter which side the horn is on. In fact, it doesn't matter at all. So I'm going to arbitrarily pick this. Do we want... What does matter, though, do we want the horn to be on the top or the bottom? On the current one, the horn is at the bottom. But because it's on the bottom, I'm not really able to have any crossbeam here. And what do we actually gain from it being lower? The only thing I can think of is that you can make it higher. Like, if you made the hexapod go as high as possible, it could clear more objects. But, like, that's not really relevant at all. I mean, you can, if you make it walk closer to the ground, this limb would be more vertical, which could potentially save power. I don't really know. All I know is that putting it up here would allow me to have a crossbeam here, and that's what I want. So I think that's what we're gonna do. Can I edit this? Configure? What? No, I don't want to configure it. Replace component? No. Like when I was placing this, I was able to move it. I want to do that again. I guess I can move like this, but I don't think it's going to stay. I guess we'll see. All right, so this is what I want. I mean, if I press OK, oh, maybe it does say. All right. So right off the bat, my first issue is that this face, I need this to be centered, right? And it's not. The prior frame was cracking here, but so I made it thicker. Not this one, not the new one, but like, you know, the old one. It was cracking right here because it was like half as thin. It was like half as thick. Put wheels at the bottom. Oh, you could. Okay. So I think what I want to do, just like right now, I want this. I mean, I want it centered left and right, but I also want it centered this way. I think I want 2 sketches. Let's add the 3rd servo mount for the tibia first. Right? No. We're gonna get rid of these. We can add the first one. Let's not even add the first one. Let's just make some sketches. All right, so we have this sketch, okay? We've got the coxa to the femur. Femur to the tibia. And then the tibia to the tibia tip. And this should allow us to center. But I want it to be this center. Sorry, I'm taking a long time on this. I just need to make sure it's set up correctly. It's so weird that like sometimes I'm just not able to move it. I don't really understand. Whatever. Okay, that's what we wanted. Okay. So now if we do this second one, this is fine. The center of this is not what I want. I want it centered between. So like this is fine for now, but This isn't centered how I want it, I think. Yeah, I guess it doesn't really matter. Like so we've got here to here, which is 10.4. The number is right here behind my camera, and here to here, which is 16.4. So like this, the servo mount's not actually the center. Now with this, I did make the servo mount the center, but I don't necessarily like that. Although maybe that's what I should do. Is that what I should do? Should the servo mount be the center? This distance is 16.4. So to make the servo mount the center, I need to bump it to the left a bit. That's 16.4. This is 10.4. So I need to bump it 3 to the left. And then it would be exactly the center. Shit, maybe. And then what? This would go down. I mean, that's an issue though. If this face went up 3 millimeters, I'd have to also bump the frame. I need to make the frame 3 millimeters thinner. Otherwise, this would be below the frame, and that would not work at all. What about like this to this? That's 16.4. And this is also 16.4. Interesting. Is this even an issue? You know, part that goes around here, part that goes around here. I'm not even sure if this is that big of an issue. Maybe we do make this centered and it's just not. It's just one, like this part of the leg just bumps out a little bit more. I'm not a huge fan of that though. Why? I mean, I literally could just. So this is 10.4. I could just bump this case out for both of them 6 millimeters. And then this would be, this distance would not be 0.4, it would be 6.4. But who cares? Alternatively, I could bump this in. Maybe that's what I do. Because I really do want this thing to be centered. Is that what I did here? I think I did. So like this distance and this distance is 9.8. This distance and this distance is not 9.8. That's not 9.8. But it's 9.2, which is basically the same. I wonder why it's different though. I need to decide this now because once I start building this, it's going to be very hard to go back and change it without completely remaking the entire thing. I'm just going to throw another one down, another one in here just to work with it. I mean, I think there's a better way to do this than by doing it by eye. But I don't really know. Maybe I can like line it up like this. Wait, how did I line this one up? Can I just like hold on. Can I duplicate this one? I can. Okay, now I want to set the rotation point. I want to set the pivot point rather to this. Now that didn't do anything. Oh, I know why. I was still editing the pivot point. My bad. Okay, so set pivot point to this. Done. There we go. There we go. Okay. Okay. Okay, now this is perfectly lined up. And everything is centered. My slight issue is just that like the servo mounts are the center, but then this left side is bumped out. Wait, is that 16.4? Maybe I'm measuring wrong. Like, what is... I'm pretty sure I'm measuring correctly. Let's just make absolute certain, though. Yeah, so that I don't want the diagonal. Yeah, it's measuring correctly. See how it's a straight line. And then, so that's 16.4. That's 10.4. So it's like a 6, not like, it's a 6 millimeter difference. I don't even think that matters though. But it matters to me. I really would like everything to be centered. So like I could take these two servos and bump them to the right 3 millimeters. That would work. But then this wouldn't be centered. No, I think I really do. I think the solution is to bump this to the right 3 millimeters. That would fix literally everything. And then all I'd have to do is reprint the frame, which I know is truly tragic, but because this would be too low. This distance being equivalent to this distance really does not matter at all. What matters is that this distance is the same as this distance because the servo mount is centered between both, you know, both sides of the servo. Okay, I think this makes sense. Just wondering if the top placement would change the stress spot. Yeah, I don't know. I don't know. I guess we'll find out. You're working on a robot with a hoverboard motor. Cool. They are heavy, so I want to CNC the rotor. Yeah, PCBWay can definitely do that. Definitely, yes. 100%. Just make sure the design you send in is correct, because it'll take like a week or so. Yeah, I mean, this doesn't really have anything to do with fusion. This is just like the actual design of the hexapod. All right, well, I mean, I printed the cases. It's a quick print though. It's not a big deal. The supports are a bit messy here. I think it matters actually. Nah, it's fine. Never mind. So I guess the question is, does this even fit? I'm not going to be using this because obviously I just changed the design, but well, I guess we'll see if what I did would have worked, right? No. There's no room for the motor. This wouldn't work. This literally, yeah. Wow. All right. Well, it's good that we're increasing the size by 6 millimeters. Okay. Something happened. I mean, I guess I'm just not taking, yeah, the motor fits, but I'm not taking into account the wire that is being routed literally on top of the motor. Fair enough. Doesn't matter. None of it matters. I'm increasing it by 6 millimeters, so it's centered. So that's where we're at. Okay. Wait, no, I'm not. Didn't I say I was bumping it 3 millimeters? What is this distance, by the way? 2.5. Okay, so I can't bump it 3 millimeters. Well, I guess I could. God, this is interesting. Well, it doesn't friggin' fit, so I gotta do something. I'm pretty sure I can get this to work. Yeah, I mean, you can very clearly see where the wire is being where it's being squished. Okay, all right. I could have it come out of a different place. I could have it come out here, but then, nah, that would get in the way of this part. So just to show you guys, the wire's being routed over top of the motor, and then the case is like squishing the wire into the motor, and it just doesn't fit. We're not out of the woods yet. I mean, okay, I guess I'll try the blue one. These supports printed a lot better. Where's the blue one? Oh, the blue one's already hooked up. I mean, does it work like this? Yeah, okay. So the blue case works for the red servo because there's actually enough room, which is kind of funny. But the red case does not work for the red servo. What are we going to do about that? because I have two problems, right? My first problem is the servo mount is not centered between the two sides by exactly 6 millimeters. Second problem is that I don't have enough space. I'm thinking I can get rid of this like bump out thing and just make it flat. So that's 2.5 millimeters. Just don't have that at all. So, and then this would be 3.5 millimeters off. And then I could just increase this by 3.5 millimeters. Alternatively, I could just increase this by 6 millimeters, but that's, I mean, that's a lot. Like, what would that even look like? Increasing this by 6 millimeters. Holy crap. So that would be 9. I mean, look how much taller that is. But, I mean, now it's centered. There's no point, though. There's no. There's no point to do that. All right. Here is what I'm going to do. Yeah, this is what I'm going to do. I think this is the best idea. All right, where is this? Let's see. Where do I extrude this thing? Yep, right here. So now I'm just not going to do that. This might change a bit. Offset, top height offset, 0. Oh, it's 2.6. Zero. Get rid of that. The rest of the design almost works. Almost. Dude, I should be able to... I think a fillet got deleted somewhere. I think we can do it right here. While we're at it, we might as well chamfer. Do we chamfer? Maybe we don't chamfer, or at least... I guess I chamfered a little bit. I don't have a variable for the chamfer, so I guess I'll just do a number. Equal distance. All right, what do we want this to be? Let's try 0.5. I don't want it to be too much. Or maybe I just do the accent chamfer. I'm not sure. We'll try this. All right. So this distance is now 13 on the dot, and this distance is now 13.9. Okay. Okay. Yeah. So all we need to do now is make this 4. And then make this 5.2. Pressing enter is not what I want to do. Okay. Now this distance is 13.9. This distance is 13.9. Beautiful. Okay, this is good. This is very good. If we... Hopefully that gives us enough room. We'll see. Let's save it and let's update. And this is going to mess up though. Well, not necessarily mess up, but just be not good. So this distance now is 2.1 millimeters in the wrong direction. And I'm a tad worried. There's a couple solutions to this, to be completely honest. We could just ignore it. Because the servo horn kind of bumps out a bit. Sure, not sure which one I'll be using. Oh, I have metal. Okay, so we have metal servo horns that, you know, go on. It does bump out quite a bit, and maybe we could take advantage of that. I think I can take advantage of that, actually. One, so I don't have to reprint the frame, and two, the thinner I make the frame, the higher chance it has to break. That 2 millimeters, that 2.1 millimeters could make the difference. Although I'm not a huge fan of the idea. Having like... So if you see, like, look how deep the servo horn goes into this part, right? I'm thinking it doesn't go deep into it. It doesn't go into it at all. It would just lay at the top and then you'd screw it in. That's my current idea. Because then, I mean, it would bump it down more than enough, right? Because, like, you can imagine the horn being, like, here. So you... Oh, no, this will be fine. This will be fine. This will be fine. All right, we're fine. I don't have to reprint the frame. Probably. Okay, so now if we update this, you'll see... I think that's perfect. Obviously, I'll have to replace these, but... 13.9, 13.9... I mean, I guess I don't have to replace them. I just need to shift them over, but I mean, it's literally just easier to replace these because I can guarantee they're centered. Although, I mean, I would like to learn like how to do this properly. So like this one, for example, I want it to be centered, and it's obviously not centered. I think that's a visual bug. How, so, okay. Free move, translate. point to point, point to position, point to point. I mean, I just want something that's in the center, right? How do I select? Okay, sure. It doesn't matter. Target point. That. Maybe that's it. I guess that's it. Yeah, that makes sense. All right. And then let's try to move this one. Point to point. Now this one's a little bit different. So the point is going to be that, and the target is going to be the same exact thing. Okay, there we go. All right, and obviously now we can just free move them. It doesn't even matter. Just wherever I want. I mean, ideally so that it really does not matter. Yeah. Oh, I guess it did matter because no. Crap. All right. Point to point again. This is tough because I want, maybe I need sketches. Because I want this one to be based off this position and then this one to be based off this position. So if this one ever moves, this one needs to move. The way I'm doing it right now, it's just, they're just set wherever. So, okay. All right. Okay. I think I got it now. We've got this sketch, which is side view, I guess. And then we want another sketch. What the hell? I didn't even choose where that sketch was. And then we want this sketch to be the top layout. And I'm just going to do this for now. Project these points. Finish the sketch. Okay. It's going to be different though, don't worry. Now, this is the side layout? Wasn't this the top layout? No, this was the top layout, sorry. It's a little confusing because the side layout is going to be top down, but it's, I think, does that make sense? Well, here's what I'm thinking. So we add this in, right? And once we rotate it the correct orientation, we're going to snap it to this point. So maybe this point, what is this point? Can this point be like the rotation axis maybe? I like that. Yeah. I like that. Okay. Okay, so this is going to be the side layout. Okay. This sketch needs to be first, and then this point will literally be Jesus, should it be at the tip of the axis or should it be the base? I feel like it should be the base. I guess it doesn't really matter. I'm not sure. I need that. I'm trying to select this inner. It doesn't matter. Okay. Okay. And then the next one is like what? Here. I don't know. And then the next one is going to be here. And then the tip is going to be there. Actually, the tip, it's going to be curved, right? So tip is going to be like here. We don't need these anymore. Yeah, we only really need one sketch. And then this is going to go to this point. It's going to move to this point. God, then what I really need is like, I need a point in the dead center between this and this to align to this point. Right? Well, okay. In the meantime, actually, no, I don't think that's true because I don't think that's true. I should be able to joint this to this. Okay. And then just give it an offset. Yeah. I don't know what that offset is exactly. Well, yes, I do. Do I? Wouldn't it just be this distance divided by 2? So 21.4. Let's try it. Yeah, baby. Let's go. All right. That's centered. Now, here's the thing. If I don't if I move this point of the sketch, if I'm able to click it, I am unable to click it. I cannot move that point of the sketch. Well, if I move, if I move this point of the sketch, the servo moves. I really thought I'd be able to drag it outside of sketch mode. Oh yeah. See? And I can change this length too. It's not letting me at the moment. Can I make the joints? There we go. Make the joints invisible. See? Look at that. Bam. I can put it anywhere. So the idea is that like I can customize how the leg is laid out, right? Okay. This is good. It genuinely does not matter where this is. Like I can personally just put this anywhere. Now, obviously I want it to be in a spot that makes sense, but like ideally this line and this line, it's like centered, right? So I guess that would be the center of this circle is centered with the center of this. How do I even do that? Am I even using that sketch? I kind of am. We're deleting it anyway. We're just going to draw this line out. Okay. So now, I mean, I can... See, this feels a little bit wrong. Like, I personally want this line to be in the center of this, but the only thing I can do is move this until... It doesn't really matter, though. Because, like, you see how this part is? Like, I can make this part do whatever I want, you know? Like, if I wanted to, I could do that. Or even that. I don't want to, but I could. But I don't know. I personally want this as straight as possible. Yeah. Ooh, okay. So this is a nice little way to customize. So like this is the Coxa length. What am I doing? Can't have spaces or underscores apparently. What? Oh, I was holding the wrong button. I was holding control instead of shift. Coxa length 50. Okay, this is good so far. Height? I guess, yeah, because like, what does height even mean? Height offset? Because a height offset of 0 would be there. And that makes sense, right? Well, no, wouldn't a height offset of 0 be this? This line being horizontal? No, that doesn't make sense either, because this isn't the axis. Well, it is, but I think this makes sense. I think this makes sense. So, Coxa length, Coxa height offset. I like this. We'll do, well, whatever it is right now. What is it? Oh my God. 10. Perfect. That is probably perfectly centered. All right, beautiful. And I'm designing this in a way where you can kind of like customize the dimensions of the leg pretty much however you want. Well, not literally however you want, but in ways, you know, that makes sense. Okay. I'm gonna go to the bathroom really quick. And then let's finish doing, let's do the tibia next, I think. Hey, Meshel, what's up? It's the kit is looking to cost. Oh, I'm sorry. Oh, you were asking about the right. The CNCing the metal. It's pretty expensive. Probably like a couple $100, maybe more. But yeah, if you just go ahead and order it, but don't like pay for it, it'll tell you. Yeah, let us know how much it's gonna cost. I'm curious. I'll be right back. So, before I do anything though, I do want to start printing this. I completely forgot. I'll save this though. All right, we've got the servo mount. Yeah, I mean, depending on the servo I want. Yeah, all right, let's try it. So we've got the red one on right now. And let's change the blue. No idea if this is gonna be, if this is gonna work. We'll see. Let's try it again. Okay. First off, let's put it back to red. That shouldn't have changed anything. Yeah. And let's do the other leg. All right. What offset did I did an offset. I remember what I did. Yeah, of 21.4. Okay. Here we go. This is like leg dimensions? Leg, limb, leg, joint? Leg part sizes, lengths, leg lengths. Let's call it that. Alrighty, servo mount. Let's orient it correctly, which is like that. Okay. And we are going to joint specifically that onto that. Okay. With an offset. That's what I did, right? That's exactly what I did. With an offset of negative 21.4. That is perfectly centered now. Yeah, look at that. All right. And now I can just move this anywhere I want. So if we go back to the, okay, that is super annoying. Fair enough. I think this, I mean, I guess it doesn't have to be, but I want this to be horizontal. And I want this to be Coxa, femur length. Let's do 100 for now. And then what about femur offset? Because do we just use 0? What would that even be? Or would it be an angle? Because like this isn't really an angle, this is an offset, but this from the start to the end, that is basically an angle. Do we allow the customization of that? I almost think no. The femur is just always horizontal. That simplifies things. But then we do allow the customization of this leg. Let me think for a second. Why would this need this being angled down? No, that doesn't make any sense. No, we're just gonna have it like this. Yeah, okay. It's easier to visualize it when I have those. It's like reversed or something. This is really weird. What the hell? Okay, so like what if this was at an angle? Am I curving it or like what? So like if it was at this angle, would it curve? Like how do I want this curved? I guess I would curve it up. So like if the angle was like 5 degrees, it would be a 5-degree curve. That would be kind of cool, honestly. But didn't I say I wanted something? I will consider it. So I'm going to delete this. And we're just going to have this line like this. That is horizontal. And then this angle. Whoa. Is the angle I'm talking about. Femur curve angle? Femur curve angle? 10. And this is degrees. Degrees. Thank you. So it'll be like curved a little bit. And then we should be able to set this to 0. Come on. Why can't we set the angle to 0? So now we're forced to have a curve. Yeah, it doesn't really complicate the IK because it's still a straight line. It would look cooler. Yeah, let's do it. All right, you are forced to have a curve. I will design it for I'll design it for 10 degrees, but it should work for anything. All right. And then the tibia. This definitely has a curve. So we've got ribia. Oh my gosh. Tibia length. Tibia curve angle. Okay. Okay, this is good. I'm curious how long I made this tibia. This is like way longer, isn't it? Wait, do I even... Yeah, I do. I was going to say, do I even have a variable for this? 180. Let's make this... Let's make this 165. All right. It's a great start. Wait, is this right? Sorry, I was gonna say I'm realizing. No, this is wrong. Wait, no, this is right. Sorry. Wait, no, it's wrong. Wait, this is actually wrong. This needs to be... This needs to be at this center point. So, my bad. Very fixable, though. Very fixable. There we go. So this needs to be collinear with that, and we are good to go. There we go. Now this is the actual length, not this. It's this. There we go. And frankly, we can move. I mean, just so this point is connected, this does not matter. So we want the center point, which is, I don't think that hit it. Which is there. Oh, I guess it did. And we want this to be there. And now this dimension is going to be the Coxa offset. There we go. Okay. Perfect. So there's our little leg line for the, I guess, for the kinematics. This is good. This is really good. This is yeah. This is fantastic. Okay. I think this is a good point to make like a recording, actually. Yeah, oh, whoa, hold on. That's what, yeah. Why isn't this, what's going on here? I think that's better. I think that's good. Yeah. Oh, that angle should not be able to be changed. These should all be, this should be horizontal. There we go. There we go. Okay, it's all constrained now. Perfect. Now we're good. All right. All right. Yeah, I'm gonna record a YouTube clip for this because this is a great you know, checkpoint. Did I talk about how I cared about this distance? Because I don't care about that anymore. I don't remember. This was the battery. Because your power switch to arrive. Unless then I talked about the axle there. I should have labeled these videos. Like in it's all connected to the case. Literally, it's disk, case. So making the servo, this disk keeps the solar. I don't think I mentioned it. So now that this is a lot taller, I still don't need to mention that. In fact, I don't even think I have to mention the servo case at all. All right, what am I going to say? Basically, I've got the layout of the servos implemented in a way where I can change the leg lengths and then everything updates accordingly. Yeah. All right. I'm making very good progress on the leg. I've started out by laying out the 3 servos and then making a sketch that basically constrains the servos and allows me to change their layout and allows me to change the leg segment lengths based on variables. So if we go to our variables, we've got a couple. Coxa length, Coxa height offset. So the length is pretty self-explanatory. If we increase that, it gets pushed out. If we increase the height offset, it moves up, right? Undo that. Then we've got the femur. Then we've got the femur length and femur curve angle. Yeah, the femur is now going to be curved. So the length is this line right here. So if we increase that, see what happens. And then the curve angle, if we increase that, it just raises, right? It just rises. So obviously this is not a curved line, but I'm going to design it in a way where it is curved. Okay, put that back. And then finally the tibia. So we've got very similar to the femur, tibia length. This is the end of the foot, right? And then curve angle, right? So it's going to curve down like this. What's the word with this? So with this foundation, I can now actually build the leg around these servos. And when the servos move, hopefully the leg pieces will update, correctly. I think that's good. Okay. Let's make the Coxa. This is really good. This is great. I don't think in fact, I know I did not set it up like this. Wait, maybe I did. I'm not actually sure how this is set up. I do know that the tibia is set up in a way where I can actually like change the length. So like if I make this 160, is this gonna just break it? Yeah, see, it like shrinks a little bit, but like so much stuff messes up. Oh, like the entire spring mechanism just explodes. Oh my god, this whole thing is a nightmare. All right, anyway. Coxa. We're gonna make a new component. Do not forget to do that. Name it Coxa. I mean, it's basically gonna be this, right? Like we've got a flat piece here and a flat piece here. Well, not completely flat, but you know. And then we've got a piece connecting the horn, a piece connecting the horn. Okay. Do I want this to be taller? I think I do, actually. Oh, no. Okay, so right now, I see. Yeah, right now this servo mount is centered with this servo mount. Is that what I want? Not necessarily, but I think this is fine. I actually... Do I start with this piece and this piece, or do I start with the side pieces? I mean, I'm not really sure if it actually matters at all. I think I want to start with the side pieces, actually. It would be, yeah, I'm going to start with the side pieces. The side pieces are the main pieces. Let's make a sketch. And I want this sketch to be, it's important. Like, what do I want the sketch plane to be? I guess I want it to be this. I mean, again, it doesn't really matter. It really doesn't matter. It doesn't matter. All right. Okay, sketch plane is here. I guess which part I make the sketch plane on is like I'm getting a lot of free lines if I make it on this one, if that makes any sense. So I will make it on this one. Okay. Now how close do I want this piece to get? Like for example, oh wait, I didn't actually, oh, never mind. This is perfect. I thought I chamfered it, but I didn't. Okay, cool. Did I actually not chamfer this? Yeah. Okay, let's see. Let's think. I mean, it's basically, so let's project this. And let's project, God, I mean, I guess this. That's basically all we need to project. What does the metal servo horn look like? We should, before we continue, I'm going to model that. So I'm going to go back to the servo mount. I mean, I have it right here. Really what I need to know is like how far away from the gear it protrudes. Exactly 5. Oh, that's nice. Exactly 5. And then the diameter is, I'm going to say it looks to be exactly 20. So 5 and 20, 5 and 20. Okay. Let's go, geez, let's actually go, I want to go to the right to the beginning. This should have been the first thing I did. Make a sketch. Right here. 2 circles. 1 there. 1 there. Nope, that's not what I want. I want to make a sketch here, and I said it protrudes 5. Circle, circle. Okay. So basically, I extrude this and this 5. And then I should have made a new freaking component. Let's do it. Oh, wait. I don't think I have to do it again. I have to do it again. Well, I don't have to, but I'm going to. Just to make everything neater. New component. Name it horn. Sketch. There. Let's do it again. Circle. Circle. Finish. We want to extrude that and that. 5. And then we want to extrude extrude this and this, starting here down. This probably doesn't matter, but I'm going to measure it anyway. .85, I guess. Well, not I guess. I mean, that's what... Man, that looks thicker. No, that is... Yeah, that's correct. All right, and finally, let's do the dimensions of this. So I said... Well, I didn't really get the dimension of that. That dimension... No, I'll do it anyway. This is 20. What is this? Fell off. 8.8. All right. So there's my servo horn. Do we also do the circles? .8 away from the center, rather. Nah, that's 7. That's probably 7. And then how big are the circle? The size of the circles don't really matter. It's just an M. It's just M3. We can do this sketch again. So we go line. That's a construction line. Make it straight down. I didn't mean to do that. And then this was, I said it was 7. Yeah. M3, that probably means 3. And we can rotate it here. I might as well, I'll just do this. All right, and we can revolve the cut around this axis like that. All righty. For good measure, we can do that. It's more, it's a bigger hole that's not used. There. I love it. Beautiful. I don't think this is jointed to it. Shouldn't be too hard, though. I don't even know what just happened. Okay, no, that's not gonna work though, because that's gonna be offset. Damn it. Can I? God, I just want to join this ring to this. But I can't. It's not. Is that good? Okay, I think I got it. Yeah, I got it. Okay. All right, there we go. Save. Update. Uh-oh, what happened here? Not really sure. Ooh. All right, we're gonna keep using the cache geometry then. For now. Okay, so we've got the horns. This is beautiful. Here we go. All right. Now we can actually make this part. Let's keep going. Alrighty. I'm just going to roughly sketch it out. Obviously. It needs to go to like here. Oh, it actually shouldn't go to here. It needs to go lower. If it goes to here, it's going to collide. It'll collide with this. What is this distance? 2.1. Let's make it, I don't know, 2.6, 2.5. All right. Seriously? Seriously? So you kind of see what I'm doing here. Probably. This distance is going to be already, yeah, it's driven, but that's fine because I want this to be the exact same for symmetry's sake. And now you can kind of see like, this part is like thicker than this part. It does not matter, to be clear. Really what matters, I mean, it's just like where do I want this joint to be, right? I actually like that it's higher up, because when the leg swings up, I'll have more room to work with. So I almost want to make this higher, but I mean, this is cutting it close, to be fair. Oh, why not? Why not? Okay, so what is this distance? Can we project this line? I want this distance to be 0, frankly. 0.25. All right, ready? Go to variables. Coxa height offset. 10.25. Bam. Now they're the same. Directly on top of each other. Perfect. That's going to look really good. All right. This line is irrelevant. These lines, these should be construction lines. It's these outer lines that are important, because I'm going to be directly using them for the part. Now these inner lines, though, I'm going to be using those. All right, all right. Okay, so I've realized a slight issue, but I don't think it actually is. Never mind. I'm just gonna, this thing is gonna get in the way of the piece, but it doesn't matter. I take it back. Okay. You'll see why. Okay, so this is good. This will be curved or something. This isn't even going to exist. I don't even need this at all. Whoops. There we go. Oh, okay. Hold on. I'm realizing if you ever change, I actually do want this. If you change this variable, even though I've made it like this, if you change it, it should still work. So fair enough. I think this fillet is stored here as corner radius. Okay. That is not descriptive at all. I mean, corner, yeah, all right. It's the main corner radius. I don't know why I'm searching. Corner radius. Fair enough. 7. Ooh, wait, alternatively, couldn't I just take this radius? Yeah, that's what we're gonna do. And then this is going to be filleted based on this. Perfect. Failed to solve. What, this can't be 7? Can it be 6? Why can't it be 7? Okay. I'm slightly confused. Oh, it's because this. Shit. mean, shouldn't that have moved just for this to work? That's annoying. Designing this to actually work with the variables is very annoying, but it'll be worth it, I think. Can I really not make this 7? This is super weird. And there, it's 7. Okay, let's try putting this back to 10, or maybe even just 11. Let's put it to 11. Oh, no, sorry. It actually can't. Actually, 10.25 is the max. So let's do 9. Yeah, there we go. I want this radius to be 7. Oh, now it can be 7. Okay. Of course. Okay, but what if it's 6? This shit moves. Interesting. I guess it can move, yeah. Okay, but I want it to be this. All right. What's this tangent doing? Yeah, yeah. But now, if I make this 10.25, which will line it up with the top, which is what I want, it breaks. Okay, let's just delete this. Yeah. Dude, what is happening? This should be able to work. What if I made, just as a test, can I make these two coincident? What is going on? So this can't, is there like a, why can't this go here? Okay. What if, what is this? Oh, wait. Was that all? Oh. Maybe that was the issue. Delete this line. Ah, I think I found the issue. Delete this line. Make these two coincident. I think I found the issue. And just to limit confusion, we're just gonna grab that point. What? And And that. No. And that point. Okay. So this line, which is unrelated to, yeah, that line is coincident with that. This line, not necessarily coincident with that. Okay. And now, finally, this is good so far. I know it looks crazy, but this is good. This is that. There we go. Okay. Okay. All right. It did make sense. I hate to say that it made sense why that wasn't working. Okay. Anyway, this is good. Now I guess I can just fill it this. Come on. Okay. This also equals that. There we go. So now if you change the servo mount curve, this curve will match it. Do we even want that? Like maybe I want it curvier. I don't think that would look good. Would it look good? I don't know. Oh my God. Why does it take so long to just freaking... Like, what if, yeah, I mean, what would look good? I guess that's what we should do, right? Oh my God, am I actually not even gonna use that after all that? I almost want the curve. Oh, I think this is what I want. I think I know what I want. I want this point and this point, oh my goodness, to be coincident always, which will dynamically scale the curve. Yeah, see, I think that looks the best. Yeah, that looks the best. All right, so we didn't end up doing that at all, which is hilarious. Instead, again, it's this point and this point being coincident. Perfect. All right. And because I made this offset 10.25, it's directly on top of it. But if I make it something like 8, for example, see, so it scales perfectly. All right, cool. What the hell? Why did it just disappear like that? Let's just work with 9 and I can change it later. Just so I can, excuse me, just so both sides kind of protrude a little bit. Okay. That's good. I mean, let's just test the scaling really quick, right? So let's go to 70. See, it already broke. I don't know why the lines are disappearing. The lines are like faded out for some reason. Dude, what the hell? That is fusion bug. Okay. Let's grab this circle. We already have that circle. I don't actually need that. We can just draw a line. Like so. What the heck? Oh. My camera was just angled. There we go. And what should this distance be? That is not what I wanted. What should this distance be? 15? I mean, whatever it is, this needs to be the exact same. Okay, but that is not what I should be doing. I should be doing this is collinear with this. Okay. I mean, can I move the, yeah, this is way too close. I mean, yeah, so we have this piece though. So let's project this. That's not the right one. Let's project this. And this distance, this is like the Coxa clearance distance. I don't even know. I mean, honestly, there's no reason to be able to customize that. I just need to pick a good value. We can just eye it, right? If that rotates, that should clear. Yeah. I mean, we want to make it as small as possible while still clearing, right? We'll be able to test it later. Okay, so that looks good. This is, I mean, we're done, right? That's it. That's the whole part, like legitimately, or that's the whole sketch at least. Believe it or not. All right, now we've got some questions though. So I'm basically copying this. We've got this flat piece and this flat piece, which connect to this piece and this piece. So how are we going to do that for this in a way that scales properly? Because remember, we're able to change the height offset. Okay, I'm now realizing I have not set this up in a way that is great. Because I want this to be able to, hold on. Good. If I mean this, so I should be allowed to move the servo higher and it should like curve up. Right? Does that make sense? I think someone just bought a controller. That's cool. Larry. Okay. Well, if you're in the chat, thank you. Okay, here's my dilemma. So if we offset this to 12, this is not going to work. It needs to curve up, right? Why would you even want to do this? Do I even give you the option to do this? Isn't Coxa length enough? Why would you ever want to do that? No, I'm taking this scaling away. There's no reason for this. No, there's absolutely no reason for this. This is not going to be I'm deleting this variable. Coxa height offset is permanently 10.25. Goodbye. Oh, screw you. Hold on. There you go. Why is it 10.25? Because it perfectly lines up with this. So you could argue, what if this ever changes? Well then, well wait, I just line it up with this always. So it's not even, hold on, it's not even 10.25. It's just, oh Jesus. What is this measurement? Here to here, what is this? 17.15, okay? So really it's this measurement from here to here. Can I even do that? 17, yeah, look, 17.15. I can't place that though. Oh, yes, I can. Here to here. That is always 17.15. Always, no matter what. So this will always perfectly align with that. So when I say always, what I mean is if this axle, if I ever increase this size, like if I ever bump this out, like up or down, this will change accordingly. Okay, that's good. That is it's no longer a variable you can change, because I cannot fathom a reason why someone would want to change that. I can see you wanting to flip this, but which you can do, because the way you can build this, it would work, I think. But yeah, okay. Anyway, can we delete this now? Yes, we can. Good. All right, let's continue. So simplify, less variables to deal with. That's perfect. Well, now, because we did that, we can delete this. This doesn't, you'll see what I mean, and delete that. And instead of projecting, oh my God. Okay, instead of projecting that, come on. What did I? Okay. We project the entire line because we're using the entire line. Dude, it is so laggy. Holy shit. It's not even laggy. It's just like loading. All right. So we're using that outer edge now, always. This is good. This is simpler. Simpler is good. Okay. There we go. What is it like? What is it loading? All right. So go back to here. Coxa length. What's the minimum? What's the minimum that we make this? It's not that. It looks like it's barely 40. 41. 40, is it 40.5? I mean, it's 40.5. Okay. Okay. Seriously? I can't press enter. What do I press? I need to click. Jesus. All right, min 40.5. And then when we scale it up, that's what happens. That makes perfect sense, I think. Yeah, I was thinking maybe we instead of putting the measurement here, we put it here. But so like, for example, oh my God, it would be like this. But then that creates a really like long, thin piece, depending on how long you want your coxa. Whereas this would keep it sturdy. And then if you end up, let's say you want a really long coxa, don't we all? Okay, so I said this was 5. You could probably, like, after the fact, you could put a hole. You could just extrude holes here if you wanted to. Even though this looks like ridiculous. But anyway, I'm gonna keep it to 50. This is good though. This is really good. All right. What did I do for specifically this piece? I just ran it right to there, yeah. It's gonna be a little different for this one, isn't it? Jeez, or maybe I do just... I know what I just said, but this isn't that long of a piece. Frankly, it's not even that thin. Maybe we do this. Even though I just said I wouldn't. Dude, what? So it'd be something like that. Okay. This is great. I'm really happy with this. This is, yeah, this will work perfectly. This will work perfectly. All right. Just thinking ahead a little bit. So we can imagine that this piece, this upper piece, it goes. So I'm thinking about this curve part right now. This upper piece goes down like this, and then what? I mean, maybe. So with this, I made it like the same. Maybe I want to do that. Why not? Like, why not make this 0? Why not just make these collinear? Did I do the wrong line? Are you serious? Why not make these collinear like that? $47. What is that being measured? If that's 47, but this is, why does this look so much? Why does this look so much bigger when it's, is this at 50 or 60? Coxa length. Am I measuring this wrong? How am I measuring the Coxa length here? Must be in the other sketch. Yeah, it is. That is 47. Would 3 millimeters really make it look? Yeah, I guess so. Let's put it to 47 and see if it looks like that, I guess. That would have been easier than to do what I just did. It does not look like that. Am I going crazy? Oh, I think it's because this is taller, so it makes this gap look bigger, but really it's the same. I mean, I guess we can like, here, let's measure the gap. 11.65. What's this gap? 9. Dude, I'm so freaking confused. Hold on, that's impossible. What is going on? Where am I measuring this? Coxa length is 47. What is going on? I'm going crazy. From here, yeah, 47. to here. 47. That is exactly correct. What the heck am I doing here? That is also 47. Dude, I'm so freaking confused. I mean, this measurement's not going to work, but I'm trying it anyway. Why does the... Okay, I must have made this thicker or something. Yeah, maybe I just made this thicker. Which is why that's 9.9 and this is 11.65 or something. I don't know. Whatever. All right, doesn't matter. Okay, let's see. What's next? I mean, we're still just doing this sketch. What the hell is this? Oh, those were the curves. Okay. What is this point? And why does this point constrain everything? What the hell is this point? Yeah, whatever. Okay, anyway, we need to project this line for this piece, which is gonna look like that. Yes, this is good. And then what about this piece? So this piece is gonna go like this. Does it go all the way? It could. Would that be weird? Yeah, that'd be weird. Let's leave the air hole, I guess. So this piece can go... Oh my goodness, what is happening? We need this. Nope, that's that one. We need to project that one and that one. All right. We're gonna make it go maybe... I said to this hole, but frankly, let's just find the center. Let's do it based on the center. Let's make this 45. And let's make this 7. I don't know. Totally arbitrary. Hey, Annas, what's up? Just cleared out 2 versions of Unity and got 20 gigabytes of storage. Oh my god. Jesus. That's quite a bit. Okay, this is great. Do I make it go farther? Would it be more secure if like this part went all the way down? I feel like it would, but then like, do I screw it in here? What is this distance? 3? That's not big enough. It needs to be like 5 for a heated insert to fit at least. So really this isn't helping at all. Yeah, so this is fine. I don't know, we can do like 6. Okay, so we've got this piece, we've got this piece, and then we've got this. Oh, what is this? Yeah, what is this piece gonna look like? It goes to like here, right? Yeah. And then we've got this piece and this piece, which is this whole thing. This is great. This is phenomenal. Do we round this now or do we round it after the fact? I think we round it now. This is driven off of that. Let's do it now. $15, I don't know, $12. It doesn't have to be that big, right? Looks good to me. Oh, do we round it? I don't think we round it now. Never mind. You'll see why. I don't think we round it now. Never mind. In fact, that shouldn't be round at all. Never mind. Never mind. Okay, we're done. We can start extruding now. I'm gonna pee one more time, and then we're gonna extrude. Okay. Let's do it. Okay. Let's see. Right off the bat, I want to get rid of it. So these holes don't matter at all. I'm just going to delete them. These are projections from making the sketch on this plane or whatever. Okay. Perfect. Okay. Extrude. This, and this. So this is the first piece. It's going to start. It's not going to start here. You'll see why. Because if it started here, well, I guess. Wait, I'm realizing now it could just start here. Never mind. Wow, by complete coincidence, this axle is the exact same thickness as the servo mount. Not that it even matters. Huh. Okay, whatever. How thick is this going to be? 8? So this thickness actually is going to dictate thickness of the entire thing. Of like the rest of the pieces. I like 8. 8 feels good. You'll notice this overlap. We will fix that later. But right now, I do want this to just be mirrored. I don't want to extrude it, though. I want to mirror it after I'm done. There's quite a bit that's not going to be mirrored, though. To be, well... For example, this hole, one side is going to be a screw hole and one side's going to be a heated insert hole. What is this thickness? $15? So 15 plus 16 is 31. That's perfect because the screw is 30. The screw is 30 long. So 31 is perfect. Because we're gonna have an identical piece on this side, and then the screw goes all the way through. Here and here. And here and here. Okay. It is super annoying that the axle has to come off for this piece to come off. Although not necessarily. I could just make this smaller. This doesn't even have to be a circle, to be honest. This literally does not, the bigger part does not have to be a circle. Whatever. Okay, anyway. Do I make another sketch? Yeah, I think I do. Should this be the heated insert side? No, let's just arbitrarily, let's make the heated insert side this side. All right, we're going to, geez, is there anything? Yeah, I mean, there's a bunch about this we want to clone. Never mind. Like the fillets, these, no, not those screws. Really just the fillets, to be honest, that I haven't made yet. Okay, but anyway, there's going to be another piece that goes here. Maybe I do. What's the overall width of this? 36. What did I do? Oh yeah, I did make it. Yeah. All right. And I'm gonna be doing a very similar thing. Like it's gonna be the exact same part. Okay. So I guess we base this thickness off the size of the screw. 31 is exactly what we wanted, right? Because this is, we also based the frame thickness off a size 40 millimeter screw, and that's 41. And we want to go 1 millimeter thicker than the screw, just because you don't want the screw poking at the bottom. All right. Yeah, I mean, the only thing we want to clone is I said fillet, I meant chamfer. I don't think it matters. Oh, it does matter. It needs to be printed on this side. What is this radius? 2. Ooh. What is this radius? 3. That's actually not big enough. What did I make this radius? Yeah, that's 5.5. Jesus. Okay. I messed up then. Okay, I need that. We're going to delete these curves. They're not in the right place. Here. It's got to be 5. This has to be 5. So they are going to get placed wherever they need to get placed. Are you serious? Jesus. This is not ideal. What is this thickness? 8. That's why. This is only 6. Okay, just to give you like an example of what I'm trying to do. I guess it doesn't have to be 5, but we're gonna have a heated insert hole, which I apparently don't have a variable for. It's 4.4. I have this number memorized. So we need to fit this circle somewhere while still having enough room. So I mean, I guess something like that, right? Okay, so like, I mean, I guess that would have worked. Wait, what did I have before? What? Oh, wait. Oh, that was so confusing. I was fine. This is the radius. This is the diameter. Oh, so it was a radius of 6. Oh, okay. What I had was fine. Well, I don't know, fine. I mean, 0.8 is not enough, in my opinion. So I guess, I don't know, where are we going to put this here? You want it to be 1, ideally. It's a weird way for this to be measured, but at least 1. Honestly, I want it to be thicker. There we go. There we go. Okay. We want enough material there to properly support this. Okay, now we should be able to do the same thing here, which we kind of already did, but we're going to do it the right way. Alrighty. Seriously? Okay, it just made me recalculate it, I guess. Okay, so let's actually place those holes now, right? I mean, there's nothing else. Oh, well, sorry. First, we need to mirror it. And we're mirroring the body. Yes, this is the body, mirror plane. Sorry, I was thinking about something. This should be a component. And then, well, it'll probably fix itself. We'll see. Mirror plane, is it going to let me have this? Yeah, there we go. Perfect. Yep, this program's a lot easier to use when everything's aligned to the grid, how you want it. So create components from bodies. Create components from bodies. There we go. This will be right Coxa frame? Sure. Or maybe just left Coxa, right Coxa. And then this will be the lower Coxa, upper Coxa. Yeah, that works. Why is this unground from parent? What does that even mean? I guess we'll find out. Let's try changing the Coxa length and seeing if it explodes. Nope, it worked perfectly. Now what? There's 4 holes. That's it. Oh, 5 right here. Let's handle this first, I think. Let's handle that last. No. We're gonna handle that right now. Okay. How are we gonna handle this? I'm thinking we create a sketch right here. Then we make this invisible and we project really this entire thing. Okay. This is really annoying. Am I in the sketch? Can I isolate this sketch? Oh, I guess I can like make the whole thing invisible. Okay, maybe not the whole thing. There we go. Okay, here we go. Just gonna make a hole, basically. Or a box. Okay, I'm realizing now these projections do not help. I just wanted this. Yeah, just this and this. I don't even... We're just gonna try this again. Okay, all we want to project is this and that. Okay. Now we can just use these lines. There we go. Much simpler. Much simpler. So now we've got this nice little box we need to cut out. Perfect. That's it. That's the whole sketch. Oh, we've got this thing. How far up do we need to go? Where's my blue servo? Oh. Okay, they appear to be the same. Okay. And it prints on this side, so it's going to print perfectly fine. All right, that's taken care of. Now we need to make these 2 holes and these 2 holes. Which side did I say I wanted to be the heated insert side? It doesn't matter. Let's just make it this side. Can I like, oh, finish sketch. Hold on. I might have messed this up. I want these two things to be a part of specifically the right Coxa. Oh, crap. Oh, did that work? No. Oh, no. Do I have to do that again? It really should be a part of this only. It shouldn't be in this entire thing. All right, I'm going to do it again really quick. All right, so right Coxa. Now we're in that active component, and I'm going to do it a way that's easier. So there's that at least. I'm just going to bring it over like this. See how quick it is when you know what you're doing? Uh-oh. Oh, wait. That's not the offset I wanted. Okay, so we want to object, and we want to start on an offset. There we go. Perfect. All right. We're still in the right Coxa. Let's do, oh, geez. I mean, we can just use the sketch for everything now that I think about it. Let's do heated insert hole width. Oh, didn't we already have this? Don't really care. We're just going to draw them again. It doesn't matter. In fact, I like this better. It's more organized. Okay. What about these? There we go. These should also be heated insert holes. This part is gonna, seriously? This part's gonna have all the heated inserts. And then you screw in from the other side. Okay. Hopefully this is, oh, it's 8. Oh my God, that's more than enough. I'd almost argue that, like, it doesn't have to be this open. 8 thickness? Wow, yeah. I guess we can use medium heated inserts for this. Okay, I don't want to extrude then. I want to do a hole. And I want it to be this. So the big one is going to be the heated insert width. And this is going to be 6. The whole thing is going to be 8. And then the smaller one is going to be the screw shaft. Do I really not have that? Okay, it's like 4. Or it's like 2 or something. Sorry. There we go. So you put the heated inserts on this side. The screw goes in through the other side. But you print it on... I want it to be the opposite. Shit. Because this is going to be really difficult to print. The overhangs. Unless I chamfer it, but that's really annoying. Do I just do what I was originally going to do? I could chamfer it. I was originally just going to make the hole go all the way through. That should be fine. I'm going to just do what I originally was going to do. All right. No, I don't like that though. Because it's going to look... It's going to look bad. Okay, so let's do this, and then let's extrude. So this is the heated insert hole. What is the size of the screw shaft? M3 screw shaft, 3.2. What was the head diameter? 5.1. I might as well add that as well. 5.5. Okay, so we're back in the sketch, and I'm going to make some more circles. And these circles are going to be the screw shaft diameter. Perfect. Oh, isn't that this? Okay. Well, at least I've got those. That's nice. All right. Now, what I can do is extrude and add material. Let's do 2 millimeters the other way. Perfect. Okay. So why did I do that? I only want the heated inserts to be inserted through this way, because if they're inserted through this way, they'll look bad, but it looks a lot better like this. Secondarily, because you can only insert them one way, and basically like you won't be able to insert them too far. The plastic will like create resistance. If it was just the hole all the way through, you could potentially just like keep pushing too far. So this is good. Great, you may say. And then we've got this hole. All right, let's do the other side now. So now we're gonna go to left coxa, It's a very similar thing, except easier, to be completely honest. We're gonna make, what on earth? We're gonna make a sketch on that plane. And we're gonna immediately make it go away. So I want to project this and this. Since we're doing holes, I just need a point. And we're making the screw holes. What the hell? Did I already have this selected? Bam, 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 bam. And this is going to be 8 is good, but we really just want it to be all the way through. This is the screw head diameter. It needs to be countersink. Let's try that again. This is the screw head diameter. This is the screw shaft diameter. Okay. All right, so if we did this correctly, we should be able to screw basically one screw all the way through this into the heated insert on the other side. It's 31 millimeters. The screw is going to be 30 millimeters. This is perfect. It's going well. The Coxa is basically halfway done. I'm going slow. I'm making sure it's exactly right, you know. So yeah, I already forgot something. So this, I forgot to make the hole on the other side. Fortunately, it's very easy to fix, or not fix, but just finish that. So we're gonna go to here. I'm pretty sure I can just mirror this. Over. I was hoping there'd be like an axis here. I'll just draw it. It's not a big deal. It's actually really easy to draw. I didn't even have to project those. I just... What? Oh, that's interesting. Should be fine though. Okay, there we go. Does this cut have to be so far? Probably not. This one definitely does. Do I do it like this anyway? You know what? No. Because it is structurally much, much better to leave some material there, in my opinion. Ooh, that's almost perfect. We can make it perfect, though. Project that line. Delete this line. We'll just redraw the lines. Not a big deal. And come on. Okay, and that is perfect. So now we have that cut here on this side. And on this side. There you go. It prints on this face and it will print perfectly. Wonderful. And then we go to the left Coxa, and I mean, this one is even easier. It doesn't need the cuts because, I mean, obviously the servo doesn't have that thing on the other side. Do we add a slight tolerance to this? So like it's easier to slide on? I think we should, especially because this is now, this is now 3D printed. This is now 3D printed as opposed to not being before. See, I'm not going to complain about the heat. I'm just going to turn it off. Jesus. Okay. Are we ready to print these two pieces? I think so. What else do we need to do? Let's check this one first. We don't have that piece. I added a chamfer, but it's not really super necessary. I will, let's go back to here. Before I mirror it, I think I am going to, I'm going to give us a little bit of space here. -0.1. Just a tad. We want it to be tight. It doesn't really need to be. I mean, it's screwed in. Okay. I don't even know if this is going to make a difference. Let's go 0.05. Okay. Because it's already pretty good. Like the 3D printed parts fitting in with each other, but that should be good. Do we do the chamfer? The accent chamfer? I don't think we need to. It's printed on this side, so we'd have to chamfer it. I don't know. What does it look like? This isn't even a good. I mean, do I just chamfer everything? That's what I did with the last one. Let's add it, use the variable. Seriously. And then if we want to make it smaller, we can in the future. There you go. All right. Is this still printable? What the hell? That is not right. God damn it. Oh, for Christ's sake. Dude, I'm gonna freaking... There we go. All right, we're back. We're fine. So anyway, those are the two pieces. I think we are good to print this. I did have 2 prints going. Yep, let's do it. Hey, Infinity, what's up? You're watching my 6-hour RC transmitter video. It's only an hour and 20 minutes. That's funny though. Yeah, I mean that video is basically for people who want to build it and who have the kit. Although you don't need the kit, you can use the bill of materials, and you know all the files and stuff. It is open source, but yeah, you might learn something from the code section of it though. But okay, anyway, I'm gonna get the prints off. All right, that was annoying. We've got the 2 cases. One is slightly taller than the other one. Let's try it. Hey, you upgraded your RAM? Nice, dude. So you can work on your project again? You're making an update. I'm making an update along with stuff. Hell yeah, you're making a new update post? That's awesome. I'll check it out on stream if you finish it, if you want me to. All right, moment of truth. Let's see if there's enough space in this. I think there's going to be. Oh my God, that's perfect. Uh-oh, but that was the taller one. All right, it's the taller one. It's the blue one. I put it on the red. Let's see if the red one fits on the red. So the red servo's taller, so its case is shorter. If its back case is shorter, if that makes any sense. Here we go. So it's not surprising that the blue one fit. Be surprising if it didn't fit. Oh my God, it barely fits. Holy shit! All right. If it's good, it's good. Oh no, I said barely. No, it fits great. Oh, I see the issue. Okay. The freaking rubber grommet thing is squishing the wires. Hold on. That should be better. There we go. It fits really nicely. And the wires aren't even getting pinched. Perfect. Let's screw it on. Where are my screws? I might even be able to make a wire channel. You know what? I think I will for the servo for the wire. This is perfect though. So basically, this wire starts on this side, and it's going over top of the motor, which is here, and it's a very tight fit. But I did make this pretty thick. I could probably make a little channel. I mean, I can just show you this, right? Like, so the motor's here. I could probably make a channel here for the wire. Because the axle's here, so the structural integrity of this side isn't super important. But with that said, it's really good. Let's put... Sorry, I'm just thinking about what I want to do. So we have this case, which is for the blue one. Remember I remade this. Yeah, so let's just reprint. Let's print 3 of these. Each one takes an hour. They take such a long time for some reason. I think it's because of all the bridging. But then I'm not gonna have time to print. Do you think it's gonna take an hour to make this? It'll be fine. All right, let's print 3 of these. And then I'm gonna update the accent chamfer as well. Let's see. Do we want to unisolate? All right, so this chamfer, I just want to make it the accent chamfer. Seriously? Do I? Okay. I did not make the variable yet for some reason. Do we make the... Nah, we don't have to reprint this. It works perfectly. Okay. So 3D print. Servo mount. Save. Yes. And we literally want to print 3 of these. Fortunately, we do not need these supports. I've designed it so it has a minimal bridge. So let's go to objects, support. And this specific one does not have supports. Oh, it's only a 30-minute print. Oh, because we made it smaller. Yep, 2 walls, everything. That is 2 walls, right? Yep, looking good. How many top layers is that? It should only be 3. It is 3, all right. Looking good. So we're gonna print it on, I'm gonna move it. I wanna try to use different parts of the bed. So we'll print it there. Print it on printer 1, because we want 3 of these, right? Well, okay, honestly, we just want 2. So that works out. Yeah, here's what we're gonna do. We're gonna print 1 on printer 1. We're gonna print 1 on printer 2. Don't give me that. Don't give me that micro SD card shit. And then we're going to go to the leg and print these 2 on printer 3. It is very nice having 3 printers, I have to say. Renaming these bodies makes it so that when I 3D print, I don't have to name it here. It automatically names it. Save. Save. Prepare. I don't know why I did that. Oh, yeah, no, I want this. And now I want this. Nice. Right, it should be Coxa right, Coxa left. I'm gonna fix that before I forget. You want the name of it first so you can find it alphabetically easier. Or rather, so it's sorted alphabetically how you expect. You'd search for Coxa and yeah. Did I actually do it wrong again? Jesus. Okay, let's try it again. See, it's, yeah. Press no. Auto. Beautiful. So yeah, I mean, this has to be printed on this side, not technically, but, and then this should be printed on this side because these chamfers are it gets very thin there. Okay, this is good though. Put it near the front. Slice. Look at that. All these prints are going to be finishing at the same time. That's convenient. Let's do a sanity check. Just go through and make sure nothing's weird. Looks perfect to me. Oh, this actually does look weird. This should probably be just completely full. For the, I'm gonna do 3 walls. I'm gonna do 3 walls, which fixes it. It adds how many more grams of filament does it add? So with 3 walls, it's 13.5. With 2 walls, okay, so it adds 2 grams. But it makes sure that it's structurally sound. You want around the heated inserts, you want a decent amount of material. All right, this is fantastic. Let's print it on printer number 3. Okay, so while this stuff is printing, we can finish the other half of the Coxa. Good timing. Oh my goodness, dude, I can't wait for this. She's back. It's so cute. I love the face that's built into the frame. File optimize. I don't know what that means, but okay. Power method, yeah. Leg storage. Yep, more compact leg storage. That's good. All right, is this using micro servos? Yeah. Oh my God, you're not gonna. I would use a PCB. This is so cool. Nice font. What? I like this piece. Yeah, this is nice. How are you gonna? I mean, I assume. Is there an axle on the other side of the servo? I assume. How are you gonna like super glue that or something? Or are you gonna do a custom servo back? Could you have used modifier meshes to make the material around the hole solid? Maybe. Yeah, you're probably right. I do like. I mean. 3 walls is good for structural pieces. I guess I could have like, yeah, what you're thinking, like use a modifier mesh here. I wonder if I could use a modifier mesh to like say only this part gets 3 walls. Cause like this, well, I guess. Yeah, honestly, I think the whole thing should have 3 walls. 2 birds with 1 stone. It makes it more structurally sound, and you know, it fills in this area. But that's a good thing to keep in mind. Not sure, and I'm not gonna lie, I don't feel like messing around with the slicer right now. I want to keep my sanity for a couple more hours. Okay. So now we're making this piece. It's pretty simple. We just need to keep in mind that we can't go up too much, or it's gonna hit the frame. So maybe we do this piece first. This piece is even simpler. Okay, Coxa. Oh, the rear air vents double as a. Oh yeah, look at that. That's clever. That's a smart way to hide the USB hole. I mean, you should chamfer it, or you should fillet it, right? To make it look like all the other holes. It's cool, though. Yeah, to do test print. Yeah, so have you printed anything? Don't take this the wrong way. I'm just curious if you've printed anything. And it's completely okay if you haven't. Oh, you have. Never mind. Because I was going to follow that up with, like, I'm curious that this frame really does not look strong. It is a circle, so maybe it's fine. Circles are pretty strong. And it just looks like one thin piece of print, you know? Like, where mine is like, and I know you're using micro servos, so that probably does not matter. Like, mine is like 2 circles, right? Filled in with infill in the middle, you know, but you're probably fine since it's micro servos. You're probably fine. You will see some flex. See, like if it, I'm not a huge fan of how these Coxas are being held onto the frame. That's probably going to bend. It looks freaking adorable though. See, this was before your remake though. Okay, and then here's your little remake, yeah. I don't know, maybe you addressed that, but it looks like, did you shove the Coxes in farther? It looks like you did, actually. It's gonna be really cool, though. Ooh, this is new. Oh, you got a PCV here. Holy shit. What are these? Oh my gosh. Oh my god. What? Are these the eye hole light things? What the heck? That's awesome. Ah, yeah, you did address that. Okay, good. Look at that. That looks much better. That looks much better. This is going to be a stress point though, right here. Probably. Maybe not. Actually, because the leg's going to push up, pushing this servo down. How thick is this? This looks like it's gonna break. I mean, is there any reason? Why not just fill this in? Because this is so thin, it looks like. I would just fill this in. Almost like go all the way around with that like ring, but then you'd need supports. Whew, yeah, this is not a very 3D printing friendly design, I'm realizing. Yeah, I'm sure you'll figure it out. It's coming along. It's coming along. I like it. All right, we've got like 25 minutes to to make this part so we can 3D print it right when the other prints are done. Let's focus. All right. So, I mean, it's just this. It's basically already done. And what do I mean by that? Well, let me show you. Can I make a new component? This is going to be called Coxa Top. And I didn't mean to do that. We literally just extrude this. This. And we're going to the other side. Okay. Now we're going to extrude this. And we're going to go to here. 2 sides. And then the other one, we're going to go to here. Okay. I think that works. Yep. Let's rename this before we forget. That's, I mean, look guys, that's basically the piece. I mean, this shit's really easy when you sketch correctly. Like we want to fill it this. We want to fill it this. What is this sketch? It's the Coxa, right? Yeah. We want to fill it that. And it's 3D printable too. We want to fill it that. We want to fill it that. Oh, we can't fill it these. We got it. If we fill it, it's not going to 3D print properly. All right, well, let's start. Let's actually start with this. Okay. So bam, bam. What do we want this to be? I want it to match perfectly with, I think it's 15 with this. How do we do that? I'm not really sure, but I know it's 15. I mean, can I like dimension this? No. I guess I could make a sketch. Should I do that? I think I will end up changing this. I'm going to make a sketch instead. So we're going to draw a sketch. We're going to project this and then make some arcs. Could I have filleted it? Probably. And now I want to create a driven. I mean, I guess it would be this divided by 2. Yeah. Kind of annoying, but whatever. At least it'll scale properly, I think. No, that's not even right. Okay, what's going on here? That's not, no, that's not correct. We're going to try something else. We're going to click this and then offset. And can we make this tangent? Yes, we can. Finish. Slight issue here. I mean, we're cutting it anyway. We just make it 30, I guess. It doesn't matter. Okay, if me making that 30, if I increase the Coxa length to 57, does it move? No, good. All right. I don't know what just went wrong there, but I don't. Oh, whoopsies. Something is, oh, seriously? Yep, we are not constrained, it seems. It's frustrating. We are now constrained. Okay, let's try that again. Glad we tested that. There we go. To see, it's a simple variable change too. All right, so back to Coxa top. Let's extrude this to the bottom. I don't know why it's I don't know why it's struggling with that. Okay, now what? I want to, let's make this invisible. I want to project this, which is the axle's, like, you know, axle part. And I don't, or I want to cut it out now, like that. There we go. Okay, now it fits around the axle. You'll have to insert the axle. I mean, there's no way around that. I mean, you'll have to, yeah, you put on the axle after this. That, yeah, that'll be interesting, but fair enough. This is good. This is good. We can fill it. Why am I? There we go. I'm going to save these fillets for the end and the chamfers for the end, because I can do them all at the same time. I can do the bottom and the top at the same time. Let's offset this face by, I think I was doing 0.05. Although this is, this will be rotating. I can always fix it, I guess. Let's try. We want it tight, but we don't want it like... See, this is making me think I want to use bearings, but I'm trying bearingless because it makes everything so much simpler. How, I mean, maybe I do use bearings. Where's my bearing? I had one. Here it is. How thick is it? It's only 7. So it would fit in this. The axle would be so small though. I'm gonna try this. And it's less hardware I need to buy. Yeah, I'm gonna try no bearings just to... Because like I can make the axle bigger too, which makes it stronger. Bigger, stronger. How's it going, Steph? All right, let's, I think that's good for the top. I mean, there's a couple more things, like, well, the screw hole. Maybe we should do the screw hole. I don't think I think I'm trying to avoid making a new sketch, but I think I just make a new sketch. Although, nope, I think I can just do that. Cool. Normal hole, flat, no, we're going to there with a width of screw shaft. Alrighty, there you go. Perfect. So just one screw, 130mm screw that goes all the way through. Beautiful. All right, I'm curious. So this is 31 millimeters. The old one, 31.6 millimeters. Basically the same. The difference is that the old one had an additional piece to hold the shaft. This new one, the shaft is built into the servo case. Although I'm now realizing, hold on. I'm realizing now that might not make a difference. Let's measure from here. Let's measure from here to here. 42.8. And then the equivalent would be from here to here. 50. So we're about 10 millimeters thinner. Which is freaking awesome. All right, before we do the chamfers and stuff, let's do the bottom one. This is going to be equally easy, to be completely honest. So we're in Coxa. I want to make a new component. Coxa bottom. And we are just going to extrude this and this. That new body is going to be called Coxa bottom. Okay, and then we want to extrude a couple more. 2 sides. 2 here. And then this one goes to here. Okay. So far, so good. Let's make the hole before I forget. All would work as well, to be completely honest. We're going to do all. And in fact, we're going to do all for this one as well. Because if all cuts something other than what it's supposed to cut, I did something wrong. All right. Now what? I'm gonna do a similar thing. Let's go to Coxa bottom. Let's make a sketch on the bottom. Let's make this invisible. I want to project, honestly, this entire thing. Okay. Make this part now. Grab this. Offset. Delete the dimension. Make it tangent. So I'm extruding this. What else? Isn't that all I need for this sketch? It's literally all I need for this sketch. Start with getting rid of this. Okay, next. This is an interesting extrude. Let's start with just like the inner side of it. How thick do we want this to be? Well, wait. That's not even right. It'd be -2. But this isn't even what I want to do. I actually just want to start the extrude to where this thing is. So instead of offset, I'm just going to do an object. And I'm going to attempt to click that. There. I think this is good. Yeah, that's perfect. So if we get rid of the sketch, you can see we made a hole that's like, yeah, exactly how we wanted it. Okay, now we need to make the screw holes. So, I mean, obviously it's going to... How is this going to screw in? I was going to say it screws in from the bottom, but that's not necessarily true. You could have it screw in from the inside. Never mind, that makes no sense. It needs to screw in from the bottom. So we want a big hole for the horn screw because... Yeah, this part doesn't actually screw into the center of the horn. It's screwing into the other 4. You'll see what I mean soon. So I want here, here, and here. We are going to there. It's going to be a countersink. Screw shaft, screw head. All right, simple so far. What is the diameter of that hole? 5.3. What is this diameter? 5.5. Okay, so I'm gonna make one last hole. This is going to be a simple hole, and we're just gonna make it 6. We want it to be bigger than the screw. It's going to here again. Because we want to, basically we want to be able to access the horn's center screw from that hole. Which we can. All right, this should be good. Yep, I like it. After the start, yeah. So, exactly. I'm basically just remaking the entire leg. One, so the resizing variables actually work, and 2, to complement, you know, the new Servo, because everything is going to be thinner. Speaking of which, I almost finished the Coxa, but yeah, so like a little demo of the resizing. I mean, this is probably this is definitely the easiest resize of the leg, but still, I mean, it works. And then we've got these servos, or this servo resizing as well, based on this. Oops. This is a little thin, but honestly, I think it would be fine. It's hard to say. It's hard to say. I considered, you know, I might go back on this. I considered having it scale a different way. So right now, God, I might actually go back to this. Like just looking at that. For fuck's sake. Oh my goodness. Okay. So maybe I have it scale like this. What the hell? Okay, well now something's messed up slightly, but regardless, but that just looks dumb. I don't know, but it would be so thin if. See it now. Now I have to fix a different issue. I don't know. I'm just gonna leave it how I had it for now. But if I decide that this is indeed way too thin, which I have a feeling it will be, it's gonna be putting a lot of pressure right here. Although, I mean, you have this as well, holding. It's not like everything is just pressing down there. Like this is trying to hold it up. I don't know. We'll see. But anyway, maybe don't make the Coxa this long. Well, don't make it that short. There you go. Something like that. Well, anyway, you can see that the resizing is working pretty nicely. Let's finish up the Coxa. Now that we have both pieces made, we should be able to chamfer it pretty nicely, I think. I mean, I'd love if I could just do this and this. We'll see. It's honestly not bad. Can't do that though, unfortunately, because this part, actually, I take back what I said. I'm not sure. I like how it looks with this one, to be honest, where it's not chamfered and it kind of like surrounds it. With it chamfered, it just looks, kind of looks bad. It looks unintentional. So let's try the other way. We just click this, click this. The sketch, I think, is messing things up. Yep. I agree with the decision I made in the past. Looks a lot better. So now let's try to get rid of these sharp edges. I'm going to isolate this. I'm going to... Okay. I don't think we can fillet this. I think we have to chamfer it. The sharp point fillet doesn't really work from my experience. Oh, for Christ's sake. Okay. Maybe we do this before. Okay. Let's go back and let's edit the sketch. It's the wrong sketch. I'm not even in the frickin'... Let's go into Coxa top. Okay, so it's this sketch? Yeah, it's this sketch. Do I actually have to add the frickin'... I have to add it in manually. That sucks. All right. It's fair. You know, I bet you I had to do the same thing for this. I'm almost positive. I don't care enough to check, though. Maybe I do. I care enough to check. Nope. I just didn't have as extreme points, I guess. I guess we can try filleting it. To be fair, I did not try filleting it. Whatever, dude. All right. Okay. This piece is printed on this edge, so we're going to do a chamfer here. (45°), and then we can fillet that edge. For this, I don't even think we. We'll just add it in. We'll just do this. I hate this solution, but it is the solution. I hate it. I hate it so much. Like, I should be able to fillet this no problem, but whatever. And I'm not mirroring anything. This is just a nightmare. All right. Just an absolute nightmare. Wait, why did I? Oh. Oh, crap. That's why. I forgot one. And at least it works, but I spoke too soon. What the heck? Dude, like, actually, can I seriously not chamfer this? Part of me wants to just completely undo. Okay, so this is chamfered. What do I do with this? Like, I can't fillet it, right? I can't fillet it. What does this mean? I can't chamfer it. Wait, did I just have to pull it the other way? Oh, okay. Wait, so can I chamfer these? Holy shit. Wait, I can oh my gosh. All right. Undo everything. Just undo the sketch. I'm pretty sure I tried that, but I guess not. All right. All right. All right. All right. I guess we do it in Coxa. We're chamfering. We can fillet it after it's chamfered a bit. Oh, it was because I selected all of them. I understand. So let's go to the top then. And let's only do maybe these. Jesus. I swear to God, if this doesn't work. Dude, I just did it. Okay. Can I fill it this now? I bet you can. Yeah. So stupid. Why doesn't that work? Losing my mind. Are you kidding me? Wait. I saw it work. I see it work. I cannot leave it like this. Do I just cut it after I chamfer? Do I just make the cuts now? This is dumb. I should be printing this right now. Dude, there has to be a way. What if an offset face? I don't think that's, I mean, it's not a face. No way. Press pull. Yeah, no way it was correct. Okay. Okay, yeah, sure. Surely I can chamfer this. Okay, I was ready to get mad. Okay, I can chamfer it. Okay. This is good. This is good. Now, these sharp edges need to be fixed somehow. But I am unable to frickin'. Yeah, no, that's okay. I'm trying everything. I just, I don't know. I think I need to make another sketch. Hey, Viduna, what's up? I am just having a great time with this. Super duper great time. What's the error showing in the bottom right? I'm exceeding something, but I mean, what am I supposed to do about that? I don't know. We're just gonna try this. I'll do the other side if this actually works. So dumb. The fact that I have to do that is so stupid. But here we are. Okay, well, I found a solution that I'm happy with. It's just such a horrible solution. Horrible, horrible, horrible solution. Are you freaking kidding me? What are the chances I can mirror this? No, of course not. Why would that work? Why would that work? That would be too easy. No. Yeah, there's no way. No way. Oh, wait. Identical kind of works. I don't trust it. I do not trust it. So we're just gonna do this. Start here. Go to here. Cut. Go to this fillet. Add in the others. Alrighty. That was annoying, and it should have just been able to be done with a fillet, but fair enough, I guess. Okay, these should be ready to print. I need to give this some room, though, I think. We'll go back to the Coxa bottom. Where should we do this at? We should probably do it like here. And this doesn't need to be snug. It's screwed in very tightly. We'll do 0.2. I don't even know what to call it. All right. Did I forget anything? I guess we'll find out. I guess now is a better time than any to go into the assembly. Can I see just active projects? All projects. Oh, I'm 9 of 10. Okay, that's fine. I want to make the assembly editable. Yep, that's okay. Yeah, exactly, Jesse. That's what I had to do. I just shouldn't have had to do it. Which is frustrating, but it's fine. Like, I know it's a sharp point, but whatever. All right, assembly. I guess we drag the body in. The problem with this. Sure. I guess it's not a problem. We can just go into here and make the servos invisible. Yeah, okay. That's fine. And now we bring in the leg. She's a beaut. Oh, baby. Okay. Look at that. Something's wrong. Huh. What the hell is this? Hold on. Let's just save it. Let's go back to leg. I mean, I guess we joint it now, right? Seriously, what? That is correct. I guess. I mean, they both shouldn't be Revolut. Let's just do this for now. That doesn't need to be a joint. These are all just together. This should be a rigid group. Yeah. It's kind of annoying that it doesn't spin. It like updates after the fact though, and I'm pretty sure if I joint. Okay, let me confirm that. Yes. So now if I go to this joint, oh no. I was expecting this to move with it while I like test it or you know, while I. Well, that's annoying. All right, whatever. Well, I guess I can just undo to this. Huh. All right. Save. Okay. This is Fusion 360. I always use as-built joints. What do you mean by that? Who should I watch to learn inverse kinematics? Not me. There's some tutorials. There's quite a bit of tutorials. I mean, you can literally search like how to do robot arm inverse kinematics. Oh, it's a joint type? Interesting. Holy shit. Oh my God. Are you serious? Is this what I needed? As built, that's what? Select a snap point. Is it that easy? Dude, are you serious? Oh my God. Oh my God. Dude, oh my God. I have been like doing this bullshit, all right? Like for my entire life. Okay, anyway, is there an easy way I can like demo this? The one issue with the as-built joint is that okay, we have some issues. Okay, it's very nice to know that. I am gonna go back to this though, make this a rigid group and then just manually joint this because of the issue you just saw, and so I can do something like this. But that is very nice to know. Very, very nice to know. Okay. So maybe only do as built for rigid stuff, but I don't know. I'll figure it out. Yay, almost. The other servos are gone, but I guess we can add, no, there's no point to add them back yet. All right. Oh, I don't think I need to add them back. Oh, shoot. I think this isn't gonna work. I jointed the servos onto the sketch. I thought I would have an update. Oh, see, now I can't even... Well, I guess it doesn't matter. Do I need to separate out the... I just want to be able to move it. What the f... Oh, I think I understand the issue. Maybe. Isn't this anchored? Pin? It's pinned! Alright, I give up for now. I just want to be able to move the leg. Okay. Oh my God. I'm pretty sure if I save out the separate components and then import them into this, it would work. Oh, this isn't even connected. Oh, Jesus. Okay, I'm seeing an issue with my... I was gonna say an issue with my method, but now that I think about it, not necessarily. It's just this sketch. These servos are jointed to this sketch. Oh gosh. Do I care? I kinda care. What was my learning path? I found a tutorial that actually worked. I like to calculate it, like the actual math, and then I turned it into code, and then after like some debugging, it worked. Yeah, these type of projects are awesome. Yeah. So the reason I'm doing it like this is so I can easily resize these things. So like tibia length, for example. Well, that was not a great example to be completely honest. Femur length. See how it gets longer. And I've jointed it to this sketch. But that means that I don't know if I'm going to be able to joint it to anything else now. So like if I rotate this, the sketch doesn't rotate. I mean, I really would like to be able to move the leg within this file. All right, we can, I mean, let's see what happens. I'm pretty sure I know what's going to happen, but can we joint this? I don't have to do this anymore. Can we joint this to this? Is that gonna work? No. No, because it's already jointed to this sketch. You know what? I think I'm just gonna have to deal with it and just turn the servos off when I move the arm. Yeah. Well, that's unfortunate, but it's the price I pay for jointing my servos to a sketch. Fair enough. Maybe I do like take this. Am I able to like put this inside this? Oh, I am. Interesting. What if I do that before making it a rigid group? No, it's fine. Okay, but I put it inside it. Can I like export this or something? Or can I like save it? Save export? Can I export this little Coxa thing into the assembly instead of taking the entire leg? That would actually be a lot better. Undo, yeah, undo. Keep going. Thank you. Just undo all the way. No, not that far. Okay, stop there. So like we have this. This is great. I'm happy with this. What? Okay. Can I take specifically this. I'm realizing now that I put... Okay, there. I put the femur servo in the Coxa. Well, actually, I guess that makes sense. Never mind. Okay, can I take this and put it into the assembly? Read-only's fine. What the hell? Dude, what? What am I looking at? Oh my lord, I can't do this. No, it's not. Oh, don't you dare ruin my entire freaking file. It's not in use, you idiot. What are you talking about? Do I? Okay. All right. All right. I'll be right back. My mic was muted. While this is loading, I'm going to get the 3D prints. Yep, I'm sure a new version's landed. Yep. Okay, maintenance, March 8th, that's okay. If it doesn't let me delete this, I'm gonna lose my mind. Okay, thank you. All right, anyway, we've got our prints. They are looking good as far as I can tell. Ah, the screw holes. Crap. Do I actually have to reprint these? We'll see. Maybe if I screw them slow, it'll be fine. This is looking great, though. Yeah. Ooh, okay. Does it fit? That was loud. Yes, it fits. Okay, I just won't screw it in right now. Look at that. Ooh, that fits nice. That fits very nice. Perfect. I love it when it works first try. Will I put it on upside down? There we go. It's looking good. It's looking good. There's no reason to do the heated inserts right now. I need the other pieces first. Let's get those printed. Everything is read-only now. Never mind. That was a visual bug. All right. So we're going to 3D print. And this. So we want the Coxa bottom and top. Right. Might as well use 2 printers. Make sure it actually is good. No overhangs. Looks good to me. Save some filament, put the walls back to 2. Print. Looking just as good. All right. Just let me minimize. Oh my goodness. All right. So while that's happening, I'm gonna try to screw this together. Specifically, the servo mount. I messed up the screw holes. Well, let's fix the model first. How about that? So let's go to servo mount. The screw holes are not nearly deep enough. They need to be, well, we can figure that out, I guess. Right. 9.5 millimeters. And they're 1 millimeter. So that's great. Now, obviously, it goes into that, so we need to make these holes smaller. Not a huge deal. Just annoying. Ooh, what sketch was that? It was that one. Okay. So for this sketch, I actually want to project this hole like that. And instead of this, we're going to do this. 0.4 is probably fine. Come on, seriously. Oh, it's an implicit. Yeah, because I made it rigid. All right. Yeah, the rigid group thing is pretty freaking amazing. It just makes everything rigid, like, instantly. Anyway, this is good. This should be perfect. So that's fixed. The question is, do I have to print 2 more of them? Which would be another half hour. Hopefully not. We'll see. I mean, the screw's gonna go basically nowhere and then through the freaking hole, but I don't care what this looks like. I just want the servo to be secure. Yeah, this, oh god. All right. You know, honestly, that worked about as good as I can imagine. Look, I understand the camera does not look good right now, but you can kind of see the screw. It's good enough. Where are my other screws? Here they are. I'm only gonna do 2 because each time I screw this, it's a risk. It's a risk that it'll just explode, basically, or rip the layers apart. Okay. So we put this into here and we measure. So, let's see. 5.2. What were we expecting? $3.9. Okay. We got 3.9. Or sorry, we see 3.9. We were expecting. Let's just make sure. It's currently on red. Okay. It's currently on red. This is 3.9. We want it to match real life, all right? Oh, you know what? It's possible it's because it's not screwed in. 5. It's about, let's just say 5. Okay, so it needs to be 1.1 millimeters smaller to match this. Wait, but like if I change, hold on. This doesn't make any sense. If I change this, then this will update and this will be different. Oh, wait, don't I need to change this? Well, all right, hold on. Let's just try the blue one. Let's just make sure, even if it's off from what we want, let's make sure that they're both the same amount of off. That makes sense. If, you know, if I work here, at least you can see me do something. So that's what I'm gonna. Right? Now you can kind of see me. All right. That is a tight fit. Oh my goodness. Ow. And I put it on upside down because there's only screw holes on one side. Okay. Completely forgot. Not that the screw holes are helping that much, but because they were the wrong size. If we measure both of them and they're both the same height, we're golden. 5.15. They're the same height. Two different size servos. You can see one is blue, one's red. Two different size servos, two different size back cases, but they protrude the exact same height. Perfect. Now, the problem is that height is a different height than what's in here. I think I know the solution though. So it's protruding 5.15, all right? Which is fine. That's great. Except it's supposed to be protruding 3.9. So that's 1.25. How do we make up that gap? And I believe the solution is to go into here and increase. I already did something like that. Kind of. It's this thing. I just can't find the extrusion for it. I'm in the servo mount. Where did I make this? Wasn't it like the very first thing I did? Apparently not. There. Okay. 1.8? Nope. It's going to be 3.05. I need to add one. What's 1.8 plus 1.25? It's 3.05. Okay. Save. Maybe not save yet. I was gonna try something, but I'm just gonna. Save. Here we go. Okay, it got boosted up. Okay, it's 5.15. The measurement's down here. I know my camera's hiding it. That's awesome. So this is what it looks like in real life now. But I didn't have to change the size of this piece. Now let's just make absolute sure. So 10.10. It's the red one. 10.10. 10.10. 10.20, but it's the same. Doesn't matter. Okay. We're good to go. Awesome. Awesome. That's freaking awesome. Let me check. All right, they've got 7 minutes left. And then once those are done, I'll be able to assemble the Coxa. Let me, so I want to basically assemble two separate legs. Excuse me, at the same time. I want to assemble a blue leg and a red leg. I think. Actually, it doesn't even matter. No, they're both the same. So, never mind. What I do want to do, though, is assemble the Coxa. But I mean, I need the other two parts, right? I do, so I have some heated inserts I can insert. I'm going to do that. I guess I'll move the camera so you can see. This camera setup is like actually awful. It's like, it's horrible. All right, at least you can see what I'm doing now. So I've got 4 heated inserts here, 1 heated insert here, 1 here, and then I might as well do these 2 here. I can salvage some heated inserts from, or some, just one. There's a single heated insert that I can salvage. I might as well. Did I only print one of... I only printed one axle. Did I mess this up? Oh my god. Good timing too. The 3D print is done. Or 3D prints are done. Fix the camera. Reprint that axle. Let's see if I can fix this. I need a better camera setup. That's pretty good. Hopefully. Looking good so far. Let's try the servo horn with it. Fits perfectly. The holes are on the right spot. Yeah, looking good so far. Okay. The axle needs to go in after the fact. So that goes on like that. This goes on like that. Oh, I forgot. Oh, I forgot to test the clearance. Oh, it's close. It's close. Yikes. Also, does this even... This might not even work. This screw's not long enough either. Screw's not long enough. I'll leave the screw in, but I only have a 25 millimeter screw. It needs to be 40. So, whatever. But I'll leave them in just so it stays. I forgot to test the clearance. It barely hits. So I just make the Coxa longer. It's not that hard, but it's unfortunate. Okay, well, it's fine. Assembly might not go very well because I don't even have the right screws. Let's see if this fits. Oh, wow. It is literally perfect. It's not too tight, but there's zero, well, there's negligible slop, but this is perfect. Wow, this is perfect. All right. Oh, oh crap. I forgot to print. Crap. I should have been printing this. I raised these, but I forgot to print new ones. So that's cool. So, all right, I gotta print new axles. All right, yeah. They're pretty quick print. What is it? Servo case axle? Sure. Might as well print two. Dang. I can't really assemble it until I have this. Should I print another? I mean, I might as well print two more, right? What else do I need to print? I need to update the this. If I didn't already, I don't remember. Do I even have that on this yet? Yeah, I do. Yeah, look at those little holes. Oh my goodness. There we go. I mean, the difference is, yeah. These will finish after the stream, so I'm gonna print 3 of them actually. And we're gonna do print sequence by object. Just in case. Can't hurt. We'll level the bed too, since I don't care how long it takes. All right, and I haven't recorded a YouTube clip in a while because, I mean, I wanted to do a recording. Am I just low or yeah, I was just low. I want to do a recording once the Coxa stuff is finished, so we're close. I tried to slide it out, but the screw was in. I mean, geez, while we're at it, okay, let's, so it's like a 10-minute print. Let's try to fix the Coxa length. What did I even put it at? Didn't I make it like, yeah, I made it really small. I mean, we could How many millimeters for this to work? Five. So 48. Was it 47? I think the original was exactly 47. We're gonna do 48 just to make sure. All right, before, after. That fixes the clearance issue. Fortunately, the only thing we need to reprint it is these, and they don't even have heated inserts. These don't change at all. Like, literally, they just don't change. Great design. So that's, I mean, that's nice. Whoa. Wait a second. Uh-oh. We might need to reprint everything. Uh-oh. Oh shoot. I think we need to reprint these as well. Oh no. I can test this. Oh no. No. How did that happen? Crap. So this is 58 tall. From here to here. Let's see what V1 is. From here to here, 68. Holy shit, and that's not even including the cap. Guys, this is crazy. 72. To 61.5. Took off 11 millimeters of thickness. That much. The leg is getting this much thinner, and I could probably go thinner too. For example, like this thing does not need to be this thick. Also, I mean, what is this? Yeah, that's a millimeter. I could probably make the case a millimeter smaller. In fact, I know I could make the case a millimeter smaller. Yeah, this is good though. This is really good. I don't really have anything else to do on this stream, to be completely honest. I guess we'll wait. I was gonna say we'll wait for these prints, but I know it's not gonna fit. Okay, I can show you it not fitting. How about that? I mean, there's no point to wait for the prints since I know it's not gonna work. All right, here. Although, who knows? Maybe it will fit. I doubt it, though. I mean, will this screw even screw in? Okay, the screw does fit, which is nice, I guess. So dumb. I'm so dumb. Look at this. Can you see that? It's hard to see. Ignoring the fact that this axle is too small, which is why I'm just doing this. Can you see? Can you see this gap? Or that, like, it's not flush. I can't screw it. It's like a freaking 2 millimeter. No. Yeah, it's a 2.5 millimeter difference, which means I can't screw it in. Yeah, can you see that? I can't. So I've got to reprint these pieces completely, which I'm not going to do on this stream. But I mean, look, we're getting close. Sorry for the horrible ending to this, but I mean, look at this. We're getting there. We're getting there. I mean, even just this bottom piece, it's so, like, it's really, really sturdy. This Coxa design is really nice. Yeah, this turned out really well. Ignoring the fact that I've missized things. But I do want to just make sure. So this distance, and thanks Trey, I appreciate it, is 711, and this distance, ooh, no, 578. Did that matter? Did I care about that? I don't remember if I cared about that. I don't think I cared about it. I hope they're not supposed to be the same. Did I say 578? Okay, that's about 695 is about 711. And then this is 578. Okay, 580. All right, so it's pretty accurate to real life. I guess I decided I didn't care that. I thought they were supposed to be the same. 695. I don't remember. It doesn't matter. It literally does not matter. It's just the right side is. It's just annoying. It's just freaking annoying. Whatever. All right. Anyway, I'm calling it here, guys. Really good progress. I mean, I know it's basically just this, but there's been a lot of planning, and it's just tough to make it like work properly. Or it's time consuming rather. But we've got proper scaling. So if I go Coxa length 58, bam, it all moves over. Should you do this? Probably not, but you can. And then the other variables like tibia length, femur length work as well. So for next stream, I'm gonna work on the femur and tibia. I don't think the femur is gonna take as long as the coxa, mainly because it's really just like one plane. This was two, like you had these flat pieces and then these other pieces, which made it kind of difficult. But the femur is probably the easiest limb or the easiest segment. The tibia is going to be interesting because of the springs. but that'll give me a chance to redesign. Not redesign, but like, improve on the springs. They're already not bad at all, but I wonder if I can. Well, honestly, honestly, they're pretty dang good. I really just want to take this and copy paste it into my new design. I like this design is really well made. The tibia. I'm not happy with the femur at all. The coxa and the tibia, I'm very happy with though from the old design. All right. I'm calling it here, guys. I will record the YouTube clip once I fix everything, which will be today, but just not on stream. All right. I hope you enjoyed. I'm looking forward to my screws coming in the mail. They're coming soon. They're coming soon. Did I order it on Amazon? Let's see. Maybe they're here. That would be crazy. They were in the if they were in the mailbox, I would be kind of annoyed. Oh my god, wait. Oh, my screws aren't here yet. My power switches are here. Apparently they're on the front porch. So that's kind of exciting. My screws are coming tomorrow. Yeah, I'll be able to test the power switch in the power switch holder. But, all right. Yep. I will be streaming tomorrow, I think. Yeah, I'll stream tomorrow. We'll work on the femur and the tibia. Have a good night, guys.